Um, if you're here, it means that you care for cybersecurity, and guess what? You're at the right place. I'm excited to introduce you to CYB. It's a global initiative by Cloud Security Alliance Bangalore chapter. If you haven't heard about CYB, it focuses on cybersecurity knowledge, mentorship, and collaboration. Our goal is to empower professionals, students, and cybersecurity leaders. We provide expert insights, hands on training, and a strong learning community. So, as you all know, CSA Bangalore has been a leader in cybersecurity awareness, research, and best practices, not just in India but worldwide. So, with this SIBE, we are reaching even further. We are connecting people, starting discussions, and shaping the future of cybersecurity. So now let's talk about learning. So we are excited to launch this new series of CISSP deep dive webinars. Whether you are preparing for CISSP or just starting the journey of CISSP, this series is for you. So we will simplify complex topics, discuss real world cases, and invite experts to share insights. So, but Cyb is not just about CISSP, it's a hub for cybersecurity growth. So, we offer mentorship programs, hands on training, and expert discussions on cloud security, AI threats, zero trust, and much more. So, if you're ready to level up your cybersecurity game, stay connected and join the conversation and be part of our Cyber movement. For follow us for updates and sign up for webinars, and let's build a strong cybersecurity community together. So on that note, we'll start the session. I have Usha Kumari and Chandresh Singh, who are already a CISSP certified trainers here. So they'll be taking you through the domain 3, which is on the network security, not network security, security engineering, if I'm not wrong. Is that right, Chandresh?
Yeah,
Hello.
that's security architecture and engineering.
Security architecture and engineering. So we have two trainers here, Usha Kumari and Chandresh Singh. They'll be taking you. They'll brief little introduction of theirs, and then they'll start. If you want to get in touch with them, or you have any questions with regards to preparation on CISSP and the topics which they are highlighting here, you can get in touch with them on their LinkedIn profile or on their you can DM them, or you can always reach out to us. We will post your questions to them and get a response to you all. On that note, I'll hand over to Usha Kumari, who will be starting the session today.
Yeah. Good morning, everyone. Yeah, but I'm visible.
Yes.
Yeah. Good morning, everyone, and welcome to this session. My name is Usha Kumari M, and I'm currently based out of Bangalore. I have overall 15 years of experience in IT, and I got my CISSP certification in the year 2023. I'm currently working as a cybersecurity consultant, more of into governance, risk, and compliance for one of the international retail brand in Bangalore. So I'm into their advisory team, and my work revolves more into risk management, into ISO implementation, and advisory. So today I'll walk you through the domain 3, some of the major topics and some of the very important topics which are more testable in CISSP. Together with me is Chandresh. So we have divided the topics between us. There are a few simple topics that I'll be dealing with, and the rest of the topics will be dealt by Chandresh. So I'll quickly share my slide. I'll turn off my camera and share my slide, share my screen. Let me know if my screen is visible.
It's visible. Just keep it on presentation mode.
Okay.
Bottom right, extreme right, no? There's
Yeah.
one where you have option for Zoom, right?
Is it fine now?
No, just click there. No, it's still on the.
You can you simply press F5. and it will start the slideshow for you.
Is this fine?
On the top, there's
Just
one.
press F5 on your keyboard.
I've already done that, and on my desktop it is.
Okay, I think you may be sharing the wrong window in that case. Just stop sharing and reshare the presenter mode.
Is it visible now?
It's coming up.
Starting, given a presentation mode, no? Just click on this right hand bottom, go to the bottom right here. Yeah, after the notes, there are 4 windows, 4 icons, right? The fourth one. No, good. You're correct. Your cursor is at the right place, but you're going somewhere. No. Come down near the zoom. Zoom next to the zoom. Before zoom. Before zoom.
Just click on from current slide, and that will also start this.
Yeah, that is what I've done. But
No, do this. I'm telling you, do this. Come down here in the right hand corner where you see this 39%, right? 39%, just bottom. Zoom options are there, no?
okay.
Here, before the zoom, there's one presentation mode, right? Before
Yeah.
zoom. No, don't go there. This fourth one. Before zoom. Next one. Yes.
Is it fine now?
Yeah.
Sorry for the trouble. So, yeah, let me walk you through the agenda for today. We will be covering, as I said, some of the major topics of security engineering and architecture domain. I will discuss few topics and then I'll open the floor for questions, as well as we will be discussing few sample questions. And at the end, I'll give you a brief intro about what are the steps I took to clear my CISSP exam, my real life experience. So the domain 3 carries 13% weightage in the CISSP exam. And these are some of the important topics that we have, and few of the topics that I would be covering here. So let me start with the first topic, which is the secure design principle. Now, what is secure design principle is whenever you design any application or any system, there are certain principles that you need to follow. And why do we use these principles? We use these principles in order to make the application or the system secure in all means, okay? You know that there are 3 pillars of security, right? Confidentiality, integrity, and availability. When we talk about security, we make sure that we secure the organization or the system or the application, whatever you're doing, you always think in terms of these 3 parameters. Okay, so depending on that, we have the principles based here. You can see what are the different principles, what are the principles that we have. One is zero trust, least privilege, defense in depth. We have threat modeling, we have secure defaults, fail securely, simple, keep it simple, and privacy by design. In the next coming slides, I'll be explaining about what exactly these means. So throughout the session, I'll just go through the topics, and at the end of the session, we'll have the Q&A. If you have any questions, just keep it handy, and at the end of the session, we can discuss them. Talking about privacy by design. What is privacy by design? Privacy by design has in itself, it has around 7 principles where it revolves around the privacy of the user. Okay. For example, the first one is proactive and non-reactive. Like, for example, when you're developing any application for that matter or a system, you need to make sure that you develop the application in such a way that the system itself proactively builds some security in it. For example, if there is an application that you have developed, and there you have to enter the name of the person, then if you're entering any alphabetic number in any numeric number in it, it should avoid, it should not accept it. So that is the security, or that is one of the input validation is one of the feature that you will incorporate in your application. So the application itself should defend its own functionality. So that is called proactive and not reactive. It's not like someone has entered the wrong data and then the developers or the admin team are going and fixing it. It should not be like that. So when you're designing it, have this concept in your mind. It has to always give the proactive step. Second is privacy as a default setting. You might have used different applications, right, on your mobile or any application for that matter. You have these default settings. When you install any new application, your application will ask you, do you want to use your camera? Do you want to use your mic? So by default, the settings are set to not are set to disable, but it asks you permission. Do you want to enable it? So by default, your security should always be secure. By default, the setting is always secure. So that is what it talks about. Privacy should always be a default setting, and then it is up to the user to give the privilege or not to give the privilege. This is something that you have to bear in mind when you design your application. Next is privacy embedded into design. It's again about how you're embedding privacy into the design. So it talks about during the design phase, when you're developing an application, you have the prerequisite phase, and then comes the design phase where you actually develop the design of the architecture of the application. At that time, you have to design the application in such a way that it is not prone to spoofing attack. It is not prone to SQL injection attack. So security should start at the very beginning stage. It should not start somewhere in the development stage. Okay, this is one of the most testable concept in CISSP, where it asks you, where should you include privacy or where should you include security? It should always be in the very beginning stage. Next is full functionality. What is full functionality? Full functionality is like something like saying that, if you have booked a ticket in yatra.com, most of the application will ask you to create a profile and then book ticket or then use their services. But if you see yatra.com, without even creating a profile, you can still go ahead and book your tickets, provided you give your phone number and your email ID. So that is a very good example of full functionality, where you can get the functionality at the same time. If the user is not comfortable opening up profile with them, then that's also okay. The company yatra.com is giving you the functionality, they're earning revenue out of it. That is what matters. But at the same time, it's giving you full functionality also. So security should also be not that just you want to make the application strong, you just make it so strong that you're not giving the functionality itself is not working. That should not be the case. The functionality as well as the security should go hand in hand. So that is very important, because if your function is not working, your business is not there, then security is of no use. Okay. The next thing is respect for user privacy. Keep it user-centric. Make sure that the user details that he's entering is secure. You use your banking application. You might have seen, they make sure that the credit card information or the amount that you enter, everything is private. If someone even logs in and another user logs in also, you will not see the complete credit card details. So that much of privacy you maintain, and you respect every user's privacy. That is also very important. Next is visibility and transparency. Another next example is, when you download any application or when you're subscribing to anything, they ask you, do you want to use your data for any promotional activity? So that is the visibility or transparency that you're giving to your users. Only when they say, okay, I'm okay for promotional events, emails or promotional newsletters, then they can subscribe it. So that transparency should be there. Or sometimes you say, okay, we are going to use your data for promotional activities or for any other systems. Then that transparency should be there. End-to-end security. End-to-end security is right from the time you enter your detail, throughout the life cycle of the process, whatever is the case. If it's a banking application, right from the time the user enters till the transaction is over, the entire communication should be secure. End to end it should be secure. So these are some of the design principles that you have to have in your mind when you are designing any application or any system for that matter. So the complete life cycle should be protected. So this is privacy by design. Now let's quickly jump into two questions related to privacy by design. Which is not one of the 7 foundational principles of privacy by design and by default? I am not in the, let me check the chat if anyone is giving me the answer there. D, no. Perfect. Someone said A. Right. See, if we go here to the slide, you see full functionality. Then you see privacy as a default setting here, number 2. End-to-end encryption is number 7. And integrity and confidentiality. See, integrity and confidentiality is the foundation of security, but it is not one of the principle. We have certain principles, and integrity and confidentiality are incorporated in these principles. So it does not stand out, but it is a part of it. So you have to, so the correct answer is A. Let's go to the second question. During an audit, we discovered that a user must manually disable the location and access details to a newly built application. Which of the following is a breach of the privacy by design? Any answers there? A. Perfect. Right. Privacy should be a default setting. Okay. It should not be that, okay, the user has entered and then he has to manually disable. It should be by default, it should be disabled, and with the user's permission, it should be enabled. So now let's move to the next topic, zero trust. Zero trust. What is zero trust? Before I jump into zero trust, let me tell you what is a subject and what is an object. So if I want to access any file or a system, then I will be the subject, and the object would be the file or the application, right? So whenever a subject is trying to access the object, now the object can be any device, application, it could be any data, it could be anything, and the subject can also be an application, it can be a user itself. So whenever a subject is trying to access an object, make sure you always verify. By default, you should not trust any application. And how do you verify? You verify based on the authentication and authorization. You see whether the user is able to authenticate to the server or the object. If he's able to authenticate, then see whether he has the right permissions. When I say permissions, is he authorized to access that object? So based on these two categories, you can start trusting that application. So this is very fundamental of security. Zero trust. No, you're not going to trust anyone. Which is the highest? See, if I give you an example, if I say you, okay, I have a file, and as an administrator, I want to give few access. Which is the best access that I can give? Read only, write only, or view only? What would be the best access as per security? Anyone can give me the answer on the chat. Which is the best security? View only. Shilajit Das says view only. Any other answers? Anyone? Okay, view only. I'm getting a lot of view only. Yes, that's right. But by default, if you ask an administrator to give an access, he will say by default, I will not give any access. Zero access is the security. Even if you want to give a view-only access, he should have a permission. He should have authorization for that. He should have a business requirement, a business justification. So for security, that is the principle of zero trust. Do not trust until you have the right authorization. And after you have the authorization, go check whether he can then provide the authentication. So that is the principle of zero trust. I hope it's clear. Now let's move to the next topic. Let's quickly discuss one question on this. You can read the question. I'll quickly read. Company XYZ is growing reliance on cloud services for business critical application. Increasing cybersecurity threats, including phishing attacks and credential compromise. To address these challenges, which of the following architecture should company XYZ implement to ensure secure access and reduce the risk of unauthorized access? Any answers there? Even if it is wrong, it's fine. It's just discussion here. It's okay. Let me know your viewpoint. What do you think? My chat is not getting updated, or is it no one typing?
Most of them, they have responded B. I think one has
My chat is not getting updated. B, perfect. Correct answer is B. Because in network segmentation, perimeter-based defense, yes, these are all the parameters that we need to do. But if you're talking about overall, and he's talking about the architecture, he's not talking about just related to one segment, then it is zero trust architecture that we need to follow. Least privilege and keep it simple. Now,
Sorry, I have one question.
yes.
Where we can find out the framework of zero trust, by that we can able to look what are the component we have to implement.
Right. You can get in, you can look for NIST documents. You'll get a detailed information there.
Okay.
NIST frameworks, yeah. NIST website, if you go, you will get more detail, all the parameters, everything, all the
Yeah,
information.
because this concept is very wide because ZTNA also comes under that. So I just wanted to know the beginning, like in a framework
Yes,
perspective.
yes, yes.
Yeah, so that's
NIST
why I
will
think.
give you more information on that.
Yeah, okay, I'll try to find next year. Thank you.
Thanks. See, one of the thing with CISSP, I think this is one of the beauty of CISSP also. It doesn't dig deep into any topics. Okay, it just wants you to have a bird view of all the topics, so you know what it is actually, and you can make a managerial decision. It doesn't ask you to get into more technicalities of it. But again, it's good to have in-depth knowledge. That is always better. But for CISSP, you understand, okay, in this topic, how much time I need to spend, because at the end it is also the topic is vast, the syllabus is vast. You need to cover 8 domains, which are very lengthy, and few of the domains you might have not even studied. So it will be like starting from scratch for few of the domains. So in that case, you understand till where and how much you need to study, and then move forward. Okay. Let's move to the next slide. Yeah, least privilege and keep it simple. Least privilege, as I already discussed, what is the least privilege that you can give for any subject to access an object? It should always be 0, no access at all. No access is the least access. But then that's the best security. Sorry, not least access. Yeah. But then what is least privilege? Coming to least privilege, it is like, say, I am a user. If I have certain responsibilities to fulfill on any application, then I should be getting only those privileges, not anything more, not anything less. Okay, if you give me less access, I'll not be able to perform my duties. If you give me more, then it is again a security breach. So keep in mind that least privilege is nothing but whatever is required, give more, give that, not anything more. Okay, and keep it simple is about when you design an application, or for example, when you are, yeah, this is more about designing an application. You need to make sure that you have your application developed in a very simplistic manner. Don't make it so complicated that the user finds it very difficult to navigate through the website or navigate to the system and to see where the feature lies. You have to make it user friendly, because at the end it is business. When you talk about CISSP, you have to think like a manager, right? So at the end it is business, at the end it is revenue, at the end it is security. You need to manage both. So in that case, make sure you are providing functionality, keep it simple. At the same time, when you keep your system simple, the attack surface also becomes simple, and it is very easy to secure it as well. So don't overcomplicate it, keep it simple. That is what this topic talks about. Let's move to some questions. An organization is deploying an application that requires certain users to have restricted access to specific features based on their roles. The application interface presents only the options that the user is allowed to use, preventing access to unauthorized features. What principle is being applied to ensure that users can only interact with approved functionality? Yeah, I'm getting answers as A. Okay. See, A is definitely not the answer. I'll tell you why. Any more guesses? Okay, now D is coming up. Yes. Right. So the correct answer here is D. Role-based access control, mandatory access control, these are some of the access models that we have. Okay, constraint interfaces. Yes, these are all, see, that's what CISSP is, right? These are all very close to each other. But if you read the question very carefully, you will see certain keywords where it says prevent access to unauthorized features. Okay, and it says it can interact only with approved functionality, not anything else. These role-based access model, mandatory access model, constrained interfaces, these are actually security models. Okay, but here we are not talking about any model. He's just talking about certain features related to an application. So the answer is least privilege. You will understand this question more better when you read more on role-based access control or mandatory access control. You will get clearer view of why this was the correct answer. Next important topic is defense in depth.
One related question, may I?
Yes, go ahead.
Okay.
Your volume is very low. I can't
Yeah,
hear.
so I will speak aloud.
Yeah.
When you say these are access models and list privilege is the more correct answer. So can you just elaborate on what access model is different from list privilege answer? Like in which sense?
Yeah, see, role-based models are definitely based on your role, you will get the access. And then there is MAC, which is again a security. These are all the access models, okay? This will be,
Usha, I can take it up
yeah.
if you're okay with that.
Yeah, sure.
So, sorry, I didn't catch your name, but there are principles and there are models. So, for example, OSI is a model, but least privilege is a principle. You can enforce a principle via configuring a model correctly in your environment, vis-a-vis your business requirement and the architecture components that you have. So if you want to achieve least privilege, you can achieve it in DAC, MAC, RBAC, RBA, your ABAC, etc., etc. So consider DAC, MAC, discretionary access control, mandatory access control, role-based access control, attribute-based access control. All these are tools in your toolkit to enforce the principle of least privilege. So the least privilege is just a guiding force. And then you can use any of the tools available in your environment to enforce that principle. Did I make it clearer to you?
Yes, Chandresh, thanks.
Yeah.
Thanks, Chandresh.
No problem.
Sorry, I didn't get your name. Thanks for the question. Okay, now let's move to the next slide, which is defense in depth. Sorry for the error in the spelling there. Yeah, so defense in depth is again a very interesting topic. It is very simple. It's about, having different layers of security. Like the more layer you have, depending on the exposure, the more secure your application or your anything that you want to protect becomes, right? For example, you're constructing a house, then you make sure that you have the main gate. Then in the balconies, you make sure you have the grill so that there's too much of protection. Then you have the fire system, you have the gas leak prevention, all those systems, right? In the same way, when you're designing an office, you make sure that you have the physical security of the office, make sure that your employees are given the ID card so that only authorized people are entering your premises. You have certain you have certain policies and procedures based on which the employees and the complete organization is working on. So this is the complete layer. If you see the defense in depth, the outermost layer is all about policies, procedures. You have your training, awareness, all those things will be the outmost layer. And then comes the physical layer, where we talk about the fences, the boundaries, the CCTV cameras, the access that you provide. Second, then once you enter the office, you'll have to log into your system. Then comes the firewalls, the IDS, IPS that provides the network security to your organization. And then comes the host security, when your specific endpoints that you're trying to log into, how you protect that endpoints in terms of your antivirus, whether you're giving them, whether you are having endpoint detection and response in place, all those things. After that comes the application and data security. How are you using the secure coding principles? Are you having WAF applications? Are you encrypting your data? Do you have the DLP in place? Are you using multi-factor authentication? Do you have the right monitoring and threat intelligence in place? So every layer you get, when you're providing security, you think in terms of layers. Okay, first layer of security will be physical. Let me have the right policies in place, and let me have the security, then let me have the physical security. So this way you design. So this is defense in depth. You defense layer by layer. Yes. Can you elaborate more, Kanan?
So policy and procedures, there is no device or physical layer, right? It's more an abstract level of guidelines and rule book types.
Yes. But when certain things occur in an organization, you rely on policies and procedures. You say you're not abiding by the policy. You may think policy is very simple, but when it comes to agreements, when it comes to at a very higher level, it is one of, even when you join any company, they give you these documents to sign, right, where you're abiding to it. So that is the first thing. Before even you enter their premises, you sign those policy and procedure documents, policy documents primarily. So it may sound like, oh, it's nothing, but it has a huge impact when it comes at an organization or an enterprise level.
Understood. It's more, we are talking more about the NDAs and the vendor confidentiality agreement types, right?
Right. That policy also includes all those. Perfectly said.
Okay, thanks.
No, welcome. So let's move for some question here. An organization implements firewalls, intrusion detection, endpoint security, software and access control mechanism to protect its network. This approach is an example of which security principle? Right. Perfect. Okay, that's nice. I'm getting all correct answers. Let's move to the next slide. Threat modeling. See, threat modeling is again, okay, yes. Yeah, threat modeling again is a very vast topic. Okay, we have teams doing threat modeling if you go to different organizations. But here, when it comes to CISSP, you just have to have an overview of what threat modeling is, which is the most widely used threat model, and what exactly it does, what is the outcome of a threat model. Okay, so threat modeling is one of the very famous model that we use is Stripe. What exactly threat modeling does is you get the application, you identify what could be the possible threat agents and what could be the attacks that this application can come across. Like it can it can come across DDoS attack. It can come across, maybe an unauthorized user can log in, or maybe your information is disclosed. So you think through, you sit and brainstorm and think from all angles of how this application can get compromised. So threat modeling is more of a proactive proactive methodology. It is not reactive. See, if you talk about SIM or SOC, what you're doing, you're actually, even SIM for that matter, sorry, you're actually monitoring on a day-to-day basis to see, okay, are we getting any threats or something like that. In the same way, threat modeling is also a proactive method of identifying your possible attacks and then identifying what could be the vulnerabilities and how it can be exploited. And then you understand that every vulnerability cannot be mitigated. So you give priority to those elements, and then you propose a countermeasure of how you can fix it. So there are teams who will dedicatedly do threat modeling in companies. When the software development team develops the application, it goes for a threat modeling team. They do the analysis, they prepare the report, and then share it for the approval. And only once they approve or they give their reports, then the application, it goes into production. It depends on the company organization, but yeah, that's how it should be. Or else sometimes if it is in production, any changes is happening in the application, it again comes back to the threat modeling to do the threat modeling. Yeah.
Yeah, ma'am. One query was that whatever controls or countermeasure we take, because we are identified the threats and
Yes.
vulnerabilities. So based on that, whatever controls, measures we need to implement, that will be also covered in the threat modeling, or that will be part of the broader scope of the risk assessment or risk management, we can say.
Yeah, you rightly said, Mohan. Your job is only to identify and give a mitigation steps. Or probably you can say, what are the countermeasures? And then you transfer it. And then the next team takes it over. It also depends on different organizations, how they deal with it also. But ideally, threat modeling job is just to identify, provide the countermeasures.
Okay.
But we don't want to dig deep into it. We just want to understand what threat modeling is. So, and then how you do the threat, what exactly is the process and how you do it. So we use this in CISSP, we talk about strike model. What is strike model? You make sure that the application is spoofing proof. You make sure it is not get the data that you enter inside the application is away from any tampering attacks. Repudiation should be taken care of. Information disclosure, unnecessary information disclosure, or the attacker should not be able to, compromise on the information that is stored in the application. It should be free from any denial of service attack or any escalation of privilege. Like supposing if I'm logging in as a user role, I should not be able to, make some tweaks in the application and get the admin privileges. So all these things is more to do with the coding of the application. So you need to make sure that the application is built in such a way that it follows the strike principles. Okay, so mostly the questions will be revolving around, okay, how do you prevent spoofing? How do you prevent, what is tampering? What is repudiation? Things like that. Okay, so this is the principle. If you see the diagram, you identify threats and then you identify the priorities and then you document and validate it. That is all about the threat modeling. There's also one.
Ma'am, sorry.
Yes.
I want to ask
Yes,
one
ma'am.
question.
Yes.
In CISSP journey, is there anywhere they mentioned that how we can act after the attack?
After the attack, risk mitigation is there.
No, that risk mitigation is proactive, but what happens after the attack? I mean, is there any framework or somewhere defined in the CISSP syllabus or journey that what we should do after an attack?
See, incident response is discussed. Okay, but again, if you're talking about one specific attacks are of different types, right? It could be any sort of attack. So Depending on the attack, we will not deep dive into one particular attack, like, okay, how will you fix the say cross-site scripting attack, or how will you what will you do when SQL injection happens. That much of detail is not there. But if they ask, but they will give you an overview about how an incident is handled, how a P1 incident should be handled, what is the best practice of handling that. That way, because this is more of managerial, it will not get into the technicality of it, but it will talk about how you work on a P1 incident, how you meeting, how you actually have your steps, how you have your teams built. That is what is discussed here. Not very in detail about the attacks.
At least not very in detail. At least, is there any framework that, okay, for what I understand from CISSP in the 8 domains, that for everything they have a framework. Okay.
Yeah.
So is there any framework that explains that what after attack, what should be the framework?
No such, nothing of that I can think of. But yes, it talks only about the incident, how you manage the incident.
Okay, ma'am. Thank you so much.
You're welcome. So yeah, we have 2 questions here. Which desired security property will be exploited by information disclosure threat in Stripe? If information disclosure is happening, which security will be exploited? Yes. Right. C. Let's move to the next question. Modifying a file on the disk or a packet as it transfers the network is an example of which threat? Modifying a file. Tampering. That is, tampering is nothing but altering the file is something to do with tampering. So spoofing, tampering, where you're modifying a file. Repudiation, where you say that you have not done. You should have logs which shows that which user has performed which action. So that is repudiation. Information disclosure, your information should be confidential. Yeah. Yes, Sanket, you have a question?
Usha, in the lower half of the slides, there are certain points that are in the scope of threat modeling, apart from the stride. So the 4th activity, which is the identified exploitable vulnerabilities, isn't that is covered as part of VAPT in the SDLC lifecycle?
Right. See,
so how does it comes and align with threat model? Because as you said, threat modeling is something which identifies the potential threats and what are the remediation or mitigation actions that they can perform. But as an activity, it is the implementation will be followed through by the subsequent teams, maybe the development team or the VAPT team.
Right. Perfect. Good question. See, we have VAPT, we have vulnerability management, we have patch management also, and we have pen test team, right? Pen test also they also try to identify which are the exploitable vulnerabilities, and they exploit those vulnerabilities. And vulnerability management tries to find out what are the weakness in your system, right? How do they do it? They perform through a scan. Maybe they do a scan and they have certain tools using which they do it, right? But what makes threat modeling different from pen testing and vulnerability is something that you should know. When you're doing threat modeling, you follow these principles, okay? Spoofing, tampering, you're not using any tools. Understand that. There are now at times, at present there are tools. Microsoft has come up with certain tools which automates the threat modeling, but they're not using anything which will go and perform a scan or test the vulnerability based on the code or something like that. If you talk about pen testing, they will get into the code and then find out, okay, is there any vulnerability? Whereas if you talk about vulnerability management, they'll perform a scan to check, okay, is there any vulnerability? But here you're testing the entire design of the application. From the place where the user is entering, you're checking in terms of, okay, if any denial of service happens, is that application holding, can it withhold the denial of service, or DDoS attack, can he withhold it? So this is, you're testing the application from an aerial view. You're testing everything. Whereas here you're identifying the spoofing, tampering attacks. Can that happen? You're not using any scan tools as such. You're getting into the code details and then identifying, and then say, for example, if you're checking, okay, does it have an input validation, right? Does it have repudiation? Does it actually, when someone is performing any action, does your log file store those actions, those security logs in that files, so that SIM team or any team can go and check the security logs? It gets into that detail of analyzing a tool or an application.
Just to add to Usha's point, was it Kanan who asked the question?
No, I still have one more, but you finish your answer, please.
It was Sanket.
Okay. Yeah, Sanket. So if you know the secure software development lifecycle, and there has been recently a trend to shift left the security. There's a movement from NIST and CISSP to build applications secure by design and publish secure defaults for the customer to also be able to configure the application or use the application securely. So the VAPT comes at a certain stage in the secure software development lifecycle. When you have the application built, you'll perform a VA scan against known vulnerabilities. So you'll simply have a knowledge base or a threat intel, which will tell you that there is CVXYZ, which is having CVSS XYZ, a number, and it maps back to a common weakness enumeration, CW, something like that. This kind of a knowledge base will be there in a tool, and the tool will simply scan through the components, like which OS are you running, what build of OS is that, do I have any known vulnerability against that build of the operating system in my database? If yes, then it's a vulnerability and give it in a report. That is what a vulnerability management tool does. Does it do anything other than that?
Correct.
So what happens is, a vulnerability management tool, I'm not talking about pen testing, but a vulnerability management tool cannot tell you if there is an attack path possible. So for example, if it's a web application, say it's an e-commerce store. Now it's quite possible that it is susceptible to replay, but it won't come up in your vulnerability scan because the vulnerability scanner simply doesn't have that kind of a capability unless the replay attack for that kind of framework or the libraries or the hosting component that you're using for the web service is already a known vulnerability and is already available in the vulnerability scanners threat intel. Agreed?
Right.
So what do we do in threat modeling? We simply take that application, draw the trust boundaries. That what do my organization control? What is not in my control? Say the user, they are connecting from internet, they are not in my control. Their devices is not in my control, etc., etc. So I draw a trust boundary, and I see from where the information and what kind of information is traversing between those trust boundaries, and then I determine that whether these conditions are possible. Can this type of interaction, say a user authentication interaction, can it be spoofed? Can it be tampered? Is there a possibility of repudiation? Because my system say it doesn't authenticate, it allows access without authentication as well as authentication. In that case, repudiation is possible. So we go through all those things. We develop a data flow diagram, and it is very early in the application development. You don't have a code written yet. You have an idea, you have the high-level diagram done, and now you're simply taking all the possible attacks, seeing if it is possible in the kind of application that I'm building, and then you create a threat library basis that, or library of vulnerabilities which you think are possible, which then help you prioritize your penetration testing, or a pen tester can focus on those things to actually validate whether it is happening or not. So the whole idea of threat modeling is do it in advance, shift left the security, so that anything which is a known issue can be fixed in the design phase itself rather than having to do it afterwards. So that is how it is different from your VA and PT.
Got it. Thank you, Chandresh. Thank you.
No problem.
I have two clarifications more like, so can we compare spoofing as an impersonation and tampering as a tinkering of data?
Spoofing is impersonation.
Tampering is tinkering of
Tampering is loss of integrity. So you can say something like IMITM.
Okay. So from between threat modeling and VAPT, am I right if I say that threat modeling is a framework for audit and guideline, while VAPT is actually a testing tool?
Okay, like I explained, threat modeling comes much earlier in the phase in your software development. So
Okay.
you don't have anything that you can run a vulnerability scanner on. You only have a high-level diagram. You have an architecture diagram, and then you are supposed to just say. So say somebody is not very well versed with the security, and they don't know that they should be using RESTful APIs, and the credential should be for those RESTful APIs. They should use JWT kind of tokens, which expire on a periodic basis, etc., etc. Those kind of issues come up in your threat modeling. That you tell the developers that, guys, you're using basic authentication using user ID password. You have hard coded it in your front end, which is a very, very bad practice. So why not just simply use a credential store or HSM, where you store your JWTs or you store your bearer token, which is then used for a JWT, which is only valid for a short span of time, say 2 hours, 4 hours, 24 hours. So that kind of advisory is done in threat modeling. So you just see, you look at what you're dealing with, you figure out what can go wrong, and then you tell the developers that what needs to be done to fix it. And then you check post that is the design remediated now or not. And remember, it is all happening on a design. It is not happening on an actual product. So
understood, but there are times when threat modeling was not a part of the earlier design and someone is trying to do it now. Is that even a possibility?
Post-facto threat modeling is all right if you're introducing a major change. Generally, organizations do a risk assessment, either in a fixed frequency, or there can be trigger-based frequency, that if the application has undergone a major change, then they'll activate their whole risk assessment. And threat modeling is one of the tools in the risk assessment, the broader risk assessment.
Okay, got it. Thanks.
Cool, thanks.
Chandresh, so I just wanted to, I think threat modeling also we can do in as a reactive measure, right?
Yes,
because in the proactive we are doing, that's what.
That's what I said, that it can be
Yeah.
post facto, but
Yes, exactly.
the benefits of that may be very, very limited,
Hmm.
or it is a triggered based event, or it's an event based threat modeling that you have done. So your application has undergone a major re-architecture. Maybe you're migrating your application from on-prem to cloud. There the advantages may be higher. So it all comes down to when are you performing it, and what is it that is triggering that activity. So is it because of a periodic reassessment? Is it because of you're building a new application, or is it because of you're migrating your application, or there is a major change in the application?
Exactly. Okay. It depends on who is using as a proactive or reactive.
Sorry?
It depends who is using as a proactive measure and reactive measure for threat modeling.
I won't say threat modeling to be a proactive or reactive. It can be pre-facto or post-facto. So you can do
reactive, proactive. I mean, like once we are doing in design and deployment.
Exactly. That is.
Yeah.
So that terminology is not correct, because proactive and reactive is something related to enforcement of control. You're not enforcing a control in threat modeling. You are doing advisory. So advisory can happen pre-facto or post-facto.
Okay. Thank you.
So yes, and then Chandresh, one more question related to, so how much feasible with respect to system? Because generally for application that is okay, because application will have the trust boundary as well as we can make that. But if we have integrated system with the just like a Purdue model or maybe layered architecture,
something like a ICS environment. Okay.
yes, ICS. So ICS, we face a lot of challenge with respect to threat modeling. That's why generally we go for the risk assessment using the template of 62443. So how that is different with respect to that risk assessment and this threat modeling that generally we do for the application, not for ICS architecture.
Okay. So the concept of threat modeling will still be the same. That the 4 questions, that what are we dealing with? What is the system? What can go wrong with the system? That is where your spoofing, tampering, the whole stride or pasta or attack tree or linden, etc. will come in. Those are the models that let you figure out what can go wrong. And then comes the risk treatment piece, that how do we, now we know that there are things that can go wrong. How do we fix it? The fixing part is where it will be different from for a ICS environment, because in ICS you can have things which are running embedded operating system. You cannot run agents on it. You cannot load EDR on it. There's limited logging capability. You're bound to sometimes run older operating system, which is end of support, because your application which is running on that operating system may not be compatible with later OS, etc., etc. There can be a lot of limitations. So the risk treatment approach will be different in ICS. Everything else will be the same.
Any tool that, because generally Microsoft tool, we don't have much strength in that template, or we can say with respect to especially ICS.
So I've not come across any tool for modeling specifically for ICS. What it comes down to, how do we define the control requirements for that? So it will come down to basically do a better job with your zones and conduits, your network segmentations basically. And if there are open issues, or if it's a new system, try just considering if you can work with your vendor to just patch it beforehand. So your control, the remediation part will change slightly in ICS. The rest of the things will be the same.
Okay, thanks.
Thanks, Chandresh. Thanks everyone
No
for the
problem.
questions. Okay, now let's move. I think we're done with the questions here. Secure defaults and fail secure. So secure defaults is more to do with, as we discussed, whenever a system fails, it has to fail securely, which means it has the default, which also means that the default settings should always be secure. So these are two different concepts, that default security should always be secure. Okay, the default settings of any application should always be the secure settings. That has to be prioritized. Security has to be prioritized when you're setting the default settings of any component or any system for that matter. Okay, and system failure, whenever a system is failing due to any issue, like maybe it is an environmental issue or it has encountered any attack or whatever, it has to fail securely. When I say fail securely, it has to go to a default state where it cannot be attacked any further, and the security settings will be set to default security settings, so that no more further ramifications can be done on that particular system or that particular application. The error handling should go in a very smooth way. It should not cause any further interruptions or any major damage should happen. So it has to always fail securely. That is what this topic talks about. And now talking about the capabilities of information system, three major ones are the TCB, the TPMs, and the HSM. A trusted computing base. So what is trusted computing base? We can go through that, but before that, let me explain you what is ring protection model. Ring protection model talks about any system, okay, how exactly a system is designed. For example, if you see, this is just a framework, this is just how it should be, the ideal principle of how it should actually look like. The ring 0 to ring 4, it is being configured to. Ring 0 will hold the most advanced privileged components of any system. It could be the kernel. Mostly it has the kernel in it. And then later on the ring one, you will have the more secure boot hardware or anything, any information which is more related to any other components of the hardware which is required for booting of the system. In ring two, we talk about all the applications like any drivers or any protocols that is required for the running. And in the ring three, you have all the user applications, any critical functionality, all those, any applications that does not have any high privileges, those should be residing on the ring three. This is the overview of how ideal system should look like. So 0 to 2 will have the highest privileges, and then as you move further, the privilege should be reducing. One other important topic is the reference model. Now, what is a reference model? A reference model is basically about how this is the trusted computing base, the combination. So, the reference model talks about how whenever a subject is trying to access an object, the process that it goes through, the authentication, the authorization, the steps that it follows is nothing but the reference model. They have given a terminology, it's called reference model. So now this one, trusted computing base. Trusted computing base is all about how you design, how your system is actually made, how the subject are trying to access an object in terms of accountability, authentication, how you actually design your system. That is the trusted computing base. It includes the kernel, the features, the security mechanism, everything that incorporates for a function of a system is a trusted computing base. How well you can design your system is all about how your system is trusted. So here are a few questions. So if you have to go to this, a secure government system is being designed with a trusted computing base that is responsible for enforcing strict access control policies before any user or process can access a system resource. A specific component within TCB must be validated. Validate the access request to ensure that it complies with the security policy. Which function of within the TCB performs this validation? So this validation is mostly done by the reference model. It will check whether this subject has the authority to access or perform the specific task that whatever the subject is requesting for. So the answer for this would be reference monitor. Next, in a discussion of rings of protection, if ring 0 is the innermost ring and ring 4 is the outermost ring, which is considered to be more secure, it's 0 because there is where you store your kernel and the OS where it resides. Next is the trusted platform module. I have a question. Yes, Sanket.
Usha, one query. The options for question 1, access control list and reference monitor, they're very, very close by. But why did we go for C instead of B?
See, you have to understand there it is talking about, access control agrees. Access control is restricted to one specific application, right? But here we are not referring to any application. We are talking more about the computing base. We are talking about the policies where, it talks about the subject trying to access one of the component of the object. If it is an access control, it will be like in a specific system, or mostly it be related to, like, for example, routers access control is the ACL list in the router or in an application. Here we are talking about the TCB, right? So whenever you have this reference model, it will always be speaking about the computing base, the computer system, and the control policies, the policies that are enforced in the system.
Didn't got the last part. Can you please repeat?
Yeah, see, that's what I'm saying. No, these access control list is specific to applications, right? But this question is talking about TCB. It is talking about trusted computing base. It is not referring to any application or any system for that matter. It is talking about the computing base. It's asking about the strict policy that can be enforced on any resource, right?
We should just, if I can take it up.
Yeah.
So let me just show you a quick example. Where's that?
You want me to stop sharing?
So I'll share my screen. I have to give permissions to it. Just 1 minute. I have to. Wow, I'll have to rejoin. Just give me a second. Okay. Sorry, guys. I'm just resharing. Share one window. And then share this. Okay. So if you see this, it's a very, very simple. It's a Mac OS file information window. Is it visible?
Yeah, it is visible.
Okay. So if you see here, the concept of TCB or a reference monitor or a security kernel, these are conceptual, these are ideas. So a trusted computing base is supposed to enforce some principles. That principle can be authentication before access or authorization before access, check permissions before you give access. When I say check permissions before you give access, it can be attribute based access control, mandatory access control, discretionary access control, your role based access control. All that comes in your access control piece. So the job of a trusted computing base, which is again a theoretical, it's a idea, it's a concept. A job of a trusted computing base is to enforce some security principles. Now, how does it do it? It does it via a security kernel. So it can be hardware components, software components, which you use to enforce those things. And then there is a reference monitor. Again, it's a concept. So what does a reference monitor do? It is something which is intercepting everything. So imagine your proxy to be a trusted computing base. What do you want it to enforce? You want it to enforce the fact that the people who are responsible, first of all, who are people who should be able to access some internet resources, only they should be able to access it. And then you also control the type of websites that you can access. So if you don't want your employees to access social media, you can basically block that. So now your proxy box is a trusted computing base in this case. How is it enforcing it? There's a reference monitor, which is basically your rule engine, which is enforcing all the principles. And there you can write rules that user group this has access to these type of websites. Say your banking websites, there'll be categories of websites. Within the categories of websites, you'll have multiple URLs or IP addresses or whatever it is, IP address and port combination. So that will be there. There'll be a user group, and that is what RBAC is. You group everyone in a specific group and then map it to a specific type of resource that you want them to have access to. That is what role-based access is. And this is an example of why I'm showing this example is because this is an ACL. An ACL is nothing but this, a set of rules. It can be written in a firewall. It can be written on it is basically a property of a DAC system. So anywhere you can write rules, that is a discretionary access control system where you can actually write rules. In a Mac, the system enforces rules on you. It doesn't allow you to change anything. So First of all, the ACLs are a feature of a DAC system, discretionary access control system, and ACLs are nothing but a list of rules that this user can only read and write this file. This user, or this is a group basically, can read only, and this everyone can read only. So if you see here, the principle of least privilege and need to know is also being enforced here. So all of these things are principles. How you enforce it is something entirely different. It will. This is a simple, most simplest enforcement of that. And you can right click on your, if you're using Windows, right click on any file, go to properties. There'll be a tab called security. If you open that, you'll see the ACLs which are written there. So what I'm trying to tell is ACL is just a tool to enforce the concept of a trusted computing base. And what actually is enforcing it is a policy engine. That policy engine is your reference monitor. Does that make sense?
Got it. So just one thought. So more of the question, the answer seems like a branch versus tree versus a branch kind of options. So when the question is
Exactly.
asking you to answer in the form of a tree, you just select a tree instead of a branch.
Exactly. So in CISSP, what they expect, the IC square expects you to give the best response. So there'll be questions where you'll see responses and all will be accurate, like all will be correct. But you'll have to select only one option, and then you'll pick the best option. So if somebody says that if there is a question around uh, John is configuring their system for an environment, yeah, the recording will be made available. Yeah. So if the question is John is configuring their say Active Directory environment, and he's enforcing RBAC, what document or why is he enforcing that? It can be because of abiding to the principle of least privilege. One of the option can be that, or to enforce RBAC, or to align with the organization's information security policy. Now, do you tell me which is the right option or the best option? All three are the. He's basically achieving all three by virtue of doing that, or by matter of doing that. But which one is the best option? Is it that he is enforcing principle of least privilege? Is it that he's enforcing the RBAC? Or is it that he's abiding or aligning with the organization's information security policy?
The least privilege, least privilege principle.
It
Because
should
the other two are, sorry.
It should be the information security policy, because that is the highest level of document under which you'll have the identity and access management some standard, within which you'll have some guidance to how to do it, and that is your SOP procedure. So if you in your first domain, I think you must have covered that architecture of how the documents are organized in an organization. So you'll start with a policy. The policy will be the highest level of document that will contain all the things that you need to do in a very, very broad manner. Then you'll have within that policy will be deriving standards will be derived from that. So you have an information security policy that basically contains all the things that you should be doing. Then there'll be standards specific to how do you perform vulnerability. There'll be a vulnerability management standard, which will also include pen testing, threat modeling, etc., etc. There can be an identity and access management standard, etc., etc. Then within identity and access management, you'll have multiple procedures. So how do you enforce the principles of that standard in your Active Directory environment? How do you enforce it in SAP? How do you enforce it in Azure Cloud? How do you enforce it in AWS? All this will be covered in your procedures. So this is how the documents are generally stacked. You'll have a policy, then a standard, then your procedures. So whenever you see the biggest or the most broadest thing, just like you said, that don't answer the branch, answer the tree. So in this case, the information security policy was the tree within which everything will be encompassed. So in CISSP, you'll see options to the questions, which will all be correct, but one of which will be the encompassing or superseding thing, and that will be the best option. So they don't ask you to generally select the right option. They'll ask you to select the best option.
The example did help me understand, but I got into another confusion. So the policies are also, when they are designed or defined, and documented, they do refer to the principles of least privilege, right? When the controls policy statements are drafted.
Okay, the policies will be written to in line with your compliance requirements, the regulatory requirements, and the uh, law of land,
Mhm.
or other 2 or 3 things which are again enforced on your organization. A policy will be driven by something like I want to be compliant with ISO 27001 colon 2022 version. I want to be compliant with NIST CSF 2.0.
Mhm.
Those are the things which will drive your policy. I want to be compliant with EU CRA Cyber Resilience Act. So Act is a law of land. ISO 27001 is a regulation, and say GDPR, that again is a regulation.
Okay.
So these things will drive what goes into your policy, and then the policy will drive what goes into your and then the standard and the environment, configuration environment, will drive what goes into your procedure. Because the procedure is the lowest level of document, it is the most detailed document. It will give you a step-by-step procedure, or step basically it is SOPs. So you must be familiar with SOPs. If you have CyberArk, how do you enforce the IDAM principle in CyberArk? Your IDAM standards in CyberArk. If it is MSAD, how do you do that? If it is Azure Entra ID, how do you do that? The SOPs will be very descriptive, and all will be again deriving their power from policy, then standard, then procedure.
Okay, got it. Thanks.
Cool. No problem.
Thanks, Chandris. Thanks, Sanket. So, yeah, I would just like to say that, you understand the concepts well. And once you understand the concepts well, you have a clarity of those concepts. And then when the question arrives, you will be able to differentiate between them and then make the right choice. So once you read then you'll know how to answer the questions. Answering the questions, the type of questions that comes, then you will be able to make a better judgment once you understand all the concepts well. Yeah. So now moving to the next part, that is the TPM. TPM is a microcontroller chip which is actually embedded into the system, the computer itself, inside the microprocessor of the system. Basically, what this chip does is it has the cryptographic keys. Now, what is a cryptographic key and how it functions, Chandresh will be taking that in much detail. But for give you an overview of what exactly this chip does, it stores a cryptographic keys. It works with the BitLocker. So once the system reboots, right, it asks you for a password. So once you enter the password, it will go ahead and check with the motherboard. In this TPM chip is mostly placed in the motherboard. It will just boot, and during the boot, it will check whether it is the required. It has those cryptographic keys. It will authenticate, and once it is fine, only then the system will get activated. So this TPM is mostly a feature which is used for more secure systems.
ಇಲ್ಲಿ ಸೊಳ್ಳೆ ಕಚ್ಚುತ್ತೆ ಇಲ್ಲಿ ಜಾಸ್ತಿ ಹೊತ್ತಿರ್ಬೇಡ್ರಿ ನಾ ತೊಳ್ಕ ಕಾಲು ಹೋಗ್ಲಿ ಇಡು ಕಾಲಿಡು ಹಂಗೆ ಹಿಂಗಿಡು ಹಿಡ್ಕಂತ.
Okay, if you can.
I muted him. You can go ahead.
Yeah, so that is the functionality of a TPM. That is a trusted platform module. There's a question here, a simple, straightforward question. Sonia recently removed an encrypted hard drive from the laptop, and then she moved it to a new device because of the hardware failure. She's having difficulty accessing the encrypted content on the drive, despite the fact that she knows the user password. So here in this scenario, what hardware security feature is likely causing this problem? So the answer here would be TPM, because the TPM has encrypted the hard drive files. Okay, it is basically it's a hardware security technique that actually stores the encrypted key on the chip of the motherboard, and if anyone is trying to access it, it will prevent it, because it needs that key to unlock the system, unlock the hard drive. So this is just one concept which you should be aware of. You don't have to get into the functionality of how it works. Just understand what TPM is and what are the uses, how it benefits, and how it works in terms of security. Next is HSM. The cryptographic keys, as I said, Chandresh will be giving you more information about asymmetric and symmetric key and how it works. HSM is one of the hardware module. See, basically now in cloud also we have this Azure Vault and those key storage where you can store the keys, right? Your symmetric and asymmetric keys. So in the same way, for very important and for a lot of applications, we use this hardware security model. It is basically a hardware where you can store. It is used to store the keys. It protects the private keys. Mostly, it stores the private keys, and whenever an authentication needs to happen, it will authenticate. The system will authenticate from the HSM. It will encrypt and decrypt the data. It will encrypt the key and keep it. And whenever anyone who wants to log in, the HSM will come into picture, and then it will provide the key. You can use the key and then log in. So this is a hardware which is used to secure the keys. The organization has given private keys to access your asset. Where should the keys be stored? Always better to use a HSM, not any other. If HSM is the best way to store your private keys. Common criteria. I think I'm done with my time. Chandresh, you would like to take over?
Sure, no problem.
I will stop sharing. You can just continue with your presentation.
Great. Thanks a lot. Thanks a lot.
Thank you.
I'll start
One quick
sharing.
question.
Yeah.
Yeah. So this abbreviations, are these abbreviations detailed out in the chapters of CISSP domains?
Yes, they are.
Expected to remember them.
Yeah, they are. And once the more you read, you will have these on top of your mind. So not to worry about that.
Okay. And with, the last question was on the HSM. What does, I understand it's a hardware security module, but what is it? Is it in a physical form? What it is? Because the options of secured USB, when the slide came in, I was thinking of secured USB like an RSA token, physical token, but I got confused.
No, it's not a token system. It's a proper server which will actually store the keys.
How different is this from a password vault?
Exactly. So let me come to that. Mahendra and Saket. And HSM can come in various shapes and sizes. So if you have, does anyone of you have a digital certificate, a class 3 digital certificate, or any class for that matter? Class 1, 2, 3, any?
No.
Okay. So the RSA token that you're referring to, Saket, that's a second factor of authentication. That's a factor of authentication. That's not a HSM. What it does is it'll either work on one of the two principles. Either it will be HOTP, hash-based OTP, or TOTP, time-based OTP, and that is simply generating a string of characters, generally 6 characters. Nowadays you have software tokens for that matter. You have Google Authentication, Microsoft Authentication, Authenticator, etc., multiple software tokens. So that's a token. That's a authentication device. That's not a credential storage device, or that's not a credential storage device. Now, Mahendra, you rightly pointed out, if you're referring to, when you said password vault, if you meant something like a YubiKey, that is a HSM. So anything which has hardware security built into it, and for that matter, if you use iOS devices, you have Security Enclave, which is Apple's hardware chip, where they store all the credentials. So that works as your TCB, as well as TPM, as well as HSM, because TPM is more or less doing attestation, and HSM is doing saving your credentials or saving your secrets.
Got it.
It can act as it can basically double up. Similarly, you have Google Titan, which comes in Google phones. You have Knox in Samsung. So all of these are examples of HSM. It can come in various shapes and sizes. And again, it depends on the performance that you need from it. So if it is a enterprise environment where you're processing, say, credit card data, credit card information, you're a bank, you're performing multiple transactions, and your uh, operations per second is very, very, very high. Then in that case, it may look like a server. That same HSM can look like a server. But if you're a small organization, or if you're an individual who happens to have just a digital certificate, they need to store it in a secure place because that contains your public-private key. So that HSM can look like a USB device. So it can, the shape and size can be variable depending upon the performance requirement from that HSM. But the concept is that it is a hardware where you can store your secrets.
Got it. You were just talking about Google and Samsung, I guess, right? So what is the technologies that they use?
Samsung phones, you see Knox, secured by Knox. If you've seen that, that is that. Google Titan is basically their security key, equivalent to YubiKey. They
Okay.
also have Titan in their phones embedded. So their recent, I don't know what their chips are called, just like Apple Silicon, they have started making their own chips with on top of Qualcomm's. They customize Qualcomm's chips. So they embed their HSM in that.
Understood.
And not that the SoCs don't come with HSM. So Qualcomm chips itself come with an HSM.
Okay. Thank you.
Cool, no problem. Yeah, Deepak, please go ahead.
So, Chandresh, you were talking about hardware security model servers. Will there be a backup of that server? What if the server goes down? Are the keys back?
So say, okay, if you, the simplest example is individuals using YubiKeys. Whenever you're going passwordless and using hardware security tokens like YubiKeys, you're always advised to use more than one. So yeah, you'll have a HSM backing up the HSM data generally. It's a simple concept of failover or HA. So just like you have HA cluster in your servers, you'll have a HA cluster of your HSM as well, depending upon the criticality of the task.
Okay.
See, for example, AWS, let's say you're using password vault, right?
Exactly. Keywords are so within AWS and Azure, they'll give you keywords, but they also allow you to get a premium HSM. So keywords are software nodes, but HSMs are actually the hardware that they are running in their environment, and they can give you a shared piece of it.
And you can have a DR mechanism with different regions also, right?
Precisely, yes. In cloud, it is much simpler.
Understood.
So we can take a copy of those keys in higher available.
So it started from software only, that you were backing up your keys on your. So even if today you don't have a HSM on your machine, you can still encrypt your device with BitLocker and decrypt it with password or back it up in your AD. So it started with software only. The advantage of hardware is it generally is write protected. So nobody can tamper the information which is stored in HSM. So it is write once, read multiple times.
Okay.
That's the only advantage of an HSM. And again, HSM also runs a firmware. So there's a risk of software being used there, but it's very, very limited. Your attack surface is drastically reduced. Rather than using a simple folder in your computer to store all your secrets, you're using now a hardware which is running a embedded firmware. And now that it is detachable from your machine, so even if your machine is compromised, your HSM, your secrets are not. And HSMs are generally, like I said, write protected. So even if your machine is compromised, nobody can alter your secrets. They can use it to attest things, they can read it, but they cannot alter it. And generally, HSMs are also require authentication. The simplest example, if you're using,
More concerned on the retrieval part of it. If there is a corruption, not even the compromise part, there is a corruption, is it retrievable?
No, it's not. It's not. If you go to YubiKeys, the simplest place that you can start from is if you go to YubiKeys website, they'll always tell you to set up at least 2 keys. Because if you're only using keys, no other method for authentication. And if you lose your YubiKey, then there is no way of retrieving that account.
Okay.
Yeah, if it gets corrupted, you basically don't have it. And it's same as any data for that matter. No? If you have a single copy of a data in a server, just imagine, just forget about HSM. No trickery involved, simple, your phone. If you're storing a lot of photos in it and you're not using cloud backups, you're not backing up it on your PC or anywhere else, and you lose your phone, or say it stops working, or say the storage in that gets corrupted, will it be recoverable? It will not be. So it's same as that. It is just that it is a purpose-built hardware for storing your secrets. And because it is purpose-built, they generally write protected and other protection which is there. And you have also FIPS compliances. So if you're familiar with FIPS 2, 3 is the latest one. Federal Information Processing System Compliance, I guess that is what FIPS is. FIPS. So you have your HSM certified against that, and FIPS also dictates some physical requirements as well. So it will, since it is a purpose-built device, it will be hardened like that accordingly.
Okay. Thank you.
Cool. I'll start sharing now.
Yeah, Chandresh, you can.
Okay. Okay, I hope my screen is visible. Yeah, it is. Cool. Is it visible, guys?
Yes.
So I think Usha left at the common criteria and the evaluation assurance models, assurance levels, ELs. But I would say that it is not very, very important. If you want, I can briefly explain it to you, but it is basically a methodology of attestation of hardware. So say there is a hardware vendor, say there is a security product vendor. They make firewalls, they make softwares, and I want to be assured of whether their product is useful or not. I'll look at a sticker which basically says EL 1 to 7. There are 7 levels in evaluation assurance levels. And with each level as you go up, it is a more difficult to pass kind of test. So there'll be certain checks required for each incremental level, and the higher the better. So the organization can define that I want my firewalls to always be EL 4 plus. And then the vendor whoever is coming in, they may have multiple models. One is say EL2. So why would somebody do that? Because it saves cost to them to not go through the certification or not harden it so much, not test it so rigorously, etc., etc. So that's why vendors do it. And EL is useful for organizations to just set a filtering criteria that I want my hardware or whatever device that I'm planning to procure to be EL X plus. And that X can be anything that I need. It can be 1 till 5, 1 till 7, anything. And within EL, you have a security level that you define and a profile that you define. Profile is basically what hardware are you testing? Is it a router? Is it a switch? Is it a firewall? And then you have a testing criteria that you define basis the EL requirements. So that is what EL and CC are. CC is common criteria. It's a framework which contains a lot of controls. So depending upon what trust principles do you need to enforce in an environment, or what kind of EL level are you dealing with, your testing of control changes, or controls which are enforceable changes. So that's primarily it. It's a attestation kind of model. Okay.
Chandresh, we are
Yeah,
seeing shared responsibility
I
model in
know,
the
I know. I don't
uh,
have it in my slide. The CC and EL doesn't is not there in my slides,
okay.
and Usha has left on that topic, and that's why I said that I'll just briefly cover it, and we'll move on to shared responsibility then. Cool. Okay, so I hope everyone is familiar with what is cloud and what are the service delivery models in cloud. In cloud, you have different service delivery models, which is infrastructure as a service, platform as a service. This is infrastructure as a service, this platform as a service, and this is software as a service. Uh, Example of software as a service, Google Meet. You won't have to get a separate server. You won't have to get a different application, operating system, etc., etc., to access it. You simply type a URL, access it. So that is software as a service, a video meeting platform as a service given to you. IS is virtual machines are the most typical example. PaaS, you can have managed databases, or you can, if you're familiar with containerization, then a managed container cluster that can be a PaaS environment. So these are the service delivery models. What shared responsibility model says is, while there are certain principles of security which are here, application configuration, identity access management, etc., etc., etc. When we were on-prem, when we were maintaining all the servers, when we were responsible for maintaining server till application, everything else, all the things were in our remit. The customer was responsible for maintaining everything about that hardware till application. But when we move to cloud, since there are different service delivery models, for each delivery model, your responsibilities, you share some responsibility with the cloud service provider in order to properly secure your assets. And that is what it represents, the shared responsibility model. So as you see here, anything which is a green is a customer responsibility, and anything which is a gray is a cloud service provider's responsibility. And now there are a few things which are split responsibility. So for example, network flow controls. In an IS environment, because you can configure your VNets, you can configure your NSGs, ASGs, etc., etc. And those are basically writing ACLs. Nothing like nothing too complicated. If you want to have a simple analogy, it is like writing ACLs for how your network traffic flows, both ingress and egress. Ingress is inward traffic, egress is outward traffic. So because in an IS environment, you can attach NSGs to certain VMs, you can attach NICs to certain VMs, you can group all the things in a VNet, etc., etc., etc. That's why it is a split responsibility, because some of it you'll be writing the rules, you'll be writing the flow rules, you'll be responsible for attaching the right NSG, grouping the ASGs. And ASGs, if you're familiar with firewall rules, it is nothing but a over glorified term for objects. So in firewall, when we write firewall rules, we create objects. So say again, there's a web application and you're running multiple web servers in a HA cluster. So you create a single object for that for the IP addresses of those web servers. So say it ranges from 192.168.1.1 till 192.168.1.5. You create a single object of all these 5-6 IPs and call it a web server ingress. So next time, if you want to write a rule, an inward rule or outward rule, ideally it should be inward only, not outward, because your web server is supposed to accept traffic, not initiate traffic. So if you're going to write an inward rule, you'll write a 0.0.0/0 on source side, which is everything from the internet, and destination me, you'll simply write the web server, the object that you created, and that will basically how the firewall will interpret it is, okay, this object means these 5 IP addresses, so I'm going to allow traffic from 0.0.0/0 to all these 5 IPs. So that is how ASGs also work. You can group your resources under a simple name, and that becomes application security group. That is what ASG is. And NSG is network security group, which is nothing but like your ACLs. So a group of ACLs, that's what NSGs are. And this is what basically shared responsibility model is. So in an IS environment, the cloud service provider is hosting the entire infrastructure. They're also responsible for physical security. And since it is a virtualized environment, it must be running on some hardware. So they're also responsible for their hardware networking. And they're, like somebody pointed out, I think Kuldeep was, sorry, who was that? That there can be multiple availability zones. Sorry, was it Mohan or Mahinder? I think Mahinder was there. Who
Yeah.
pointed out that the resilience can be achieved via multiple availability zones. So all these availability zones must be hosted in a different unique data centers. So those data centers need also to be interconnected so that there's a seamless connectivity. So all those network controls lie with your cloud service provider. Your responsibility is ensuring that your virtual machines are configured correctly, etc., etc., and everything else. Like you'll be responsible to load operating system, run application, storage, identity and access management, etc., etc. Pretty much self-explanatory. Moving over to PaaS. PaaS is more abstract version of your compute. So now more and more responsibility shifted over to the cloud service provider. So they're maintaining everything till operating system. Some level of network rules you still write because you can tag pass private endpoints to pass services. You can tag it to separate VNet, etc. So it's not entirely that all the network controls are now a cloud service provider's responsibility, but it is very minuscule. That's why it is not highlighted here. You're primarily responsible for your application configuration, the application code, ensuring that you have the right identity and access management setup, ensuring that your persistent data is correctly set up. And why persistent data? Because in cloud, you need to have, so in on-prem environment, we never thought about persistent storage as we think about it in cloud, because in cloud, when you say compute, they only mean your CPU cores, memory, if you want GPU cores and VRAM, and then a OS disk, nothing beyond that. If you want to store something, once your virtual machine is spun down, you'll have to have a persistent storage. And it can come in any shape and form. It can be a managed disk on Azure, which is a PaaS component. It can be a database. It can be a storage account. It can be blob storage like S3. It's Azure equivalent of S3 buckets. So that is what persistent storage is, where you can dump your data for long-term retention. Or when your machines go down, the persistent storage persists. That's the whole point of persistent storage, that it stays after the machine is down. So that is what it is. And then you have SaaS applications where almost all the responsibilities shifted over to the cloud service provider. You have identity and access controls. So if you want to set up SSO or federated identity, you can do that using SAML, or you can have auth-o or whatever protocols that you're comfortable with, or your identity or access management solution provides that protocol. Then in that case, you can set it up. You'll also be responsible for setting the right rules if you want to enforce RBAC, etc. So that if you want to set up JIT, just-in-time privileged access management, you can set up that as well. So those are the things that you're responsible for. Everything else, which is infrastructure or application or data related, scaling requirements, everything else is taken care of by the software service, cloud service provider. So far with me, shared responsibility model basically just delineates between what are the customer's responsibility versus what is the cloud service provider's responsibilities. Everyone okay with this? Great. I'll move on to the next one. Okay. There's a quiz. What is the greatest advantage of an IaaS in private cloud over a public cloud? So the difference between a public cloud and a private cloud is, private cloud, you're hosting the entire hardware. You're also responsible for virtualization, etc. Public cloud is something like a Azure, AWS, GCP, etc. So it is accessible to all members of public. Yeah, it is dedicated resources because here there's no multi-tenancy happening. What is multi-tenancy? Basically, on a single hardware, the public cloud service provider basically will put multiple people's data or multiple organizations' data or applications in same common pool of hardware. So that is what multi-tenancy is. So there'll be no multi-tenancy in this case because you're hosting the entire thing. Okay. Now coming to security models, again, these are theoretical models, so don't worry about this too much. What you need to remember is something that I've highlighted in this deck itself. So what you need to remember is Bell LaPadula is related to confidentiality. How can you, how I remembered it when I was appearing for the exam is uh, Bell after B comes C, so it is for confidentiality. Biba, there is an I in it, so it is related to integrity. Then Clark Wilson again, there's an I in it, it is related to integrity. And unfortunately, you'll have to keep it in mind. So if you have a simpler method to remember things, because I generally have trouble remembering these things. So I just devise my own formula to just keep it in mind. You need to remember it. At least what principles of security does the model align with? Because sometimes in CISSP, you get these kind of questions. Now, again, another point to note there is, and a word of caution when I said uh, that while CISSP may have like knowledge-based questions, what I mean by knowledge-based question is, say the question comes in the exam that what principle of information security does the Bell-LaPadula model ensure? The simple answer is confidentiality, because you know that there's a mapping in this. Now, at the same time, in the CISSP exam, there are 25% of the questions which are just for quality purpose. So, and may not be scored. So please keep that also in your mind. And it is a computer adaptive test. So also keep that in mind that you cannot skip questions, and whatever you respond and however you respond bases your accuracy of responses, the difficulty of the next question is set. But again, the word of caution that there are 25% of the questions which are always going to be test questions for exam quality improvement. So don't get distracted by if you get very easy question after a very difficult one that you got the previous one wrong. That is what I wanted to actually explain, that if you get a very simple question after a very difficult question, chances are it is a test question and not that you have gotten the previous one wrong. So don't get panicked by that. Okay, cool. Now Bell LaPadula related to confidentiality, it's a model. So, and what does this model use for? If you're implementing security or if you're building an application and you want to build it securely, and the confidentiality principle is the highest importance to you, you use the principles mentioned in Bell LaPadula. Now there'll be systems which require confidentiality and integrity, and you can mix and match the principles of Bell LaPadula and Biba. Here is a summary of Bell LaPadula. What's happening there? Because it is because it is preserving confidentiality. How can you preserve it? So say you have these confidentiality tiers. This is public information. This is middle tier is internal information, and the top tier is highly confidential information. And now this is me or this is you, who has access to say one of the tiers. I have access to internal information. How can I breach confidentiality there? Honestly, I can't because it is public information. Then I move to internal information. Now I have information to all the systems which fall in the internal information classification tier. How I can breach confidentiality there? If I'm able to take data from here and write to the lower system, that is when I'll make something which is internal to the organization public. That is loss of confidentiality, isn't it? Are you with me so far? So
If
that
you
is
repeat it, Chandresh, it bounced a bit.
no problem. So I'm a user and there are 3 tiers of information classification. You're comfortable with information classification tiers?
Yes.
So the lower tier is public classification. Above that, you have internal classification. Above that, at the top, you have the confidential classification. Now, the model is going to ensure that there is confidentiality preserved in all cases at all cost. How do you preserve confidentiality in this case? And the case is the user has access to internal classification. So in this case, if the user reads the internal classification information, and they also happen to have access to the public classification system, and they dump that internal classification information into public classified system, then basically I violated the confidentiality, because it's a higher classification classified information coming to a lower tier of classification, which shouldn't happen. That is loss of confidentiality.
Right.
With me so far?
Yes.
So if you see the rules of Bell LaPadula, that is what it says, that you cannot write down because the system at the top is having higher information classification. And if you write down, basically you're violating confidentiality. Similarly, no read up. So if I'm only allowed to read public classification information, I shouldn't be allowed to read confidential information or internal information, because that's again loss of confidentiality. With me so far?
Yes.
So and the third one is no read write up down. So basically you shouldn't have access to both the kind of classifications at the same time. Pretty much self-explanatory, as long as you know what it is aligning with. So if you know Bell LaPadula is aligning with confidentiality, then in the exam you can answer the other questions which may derive from that. Okay. The most confusing term that I found personally is this star confidentiality rule, and there is a star integrity rule. So you'll have to be wary of that. Integrity always will be in BIBA. Confidentiality always will be in Bell LaPadula. And again, these are theoretical models. Don't worry about how technically it functions, because like I mentioned previously, when it comes down to technically implementing it, it can be as simple as writing an ACL or putting the user in the right group. So implementation is that, but theoretically it is this. The model is this. Again, now we have BIBA, which is integrity, which is preserving integrity. How do you preserve integrity? Again, you have the same classification tiers. How do you preserve integrity?
You cannot change the classification to a lower or a higher.
Don't worry about changing classification. Integrity is about changing information.
Information.
Yes. So that is what the rule says. No read down. If I'm a person who has access to confidential information, I shouldn't have access to public information, because then I can get something which is which shouldn't be there in confidential systems. And if I modify it basis that information, it can modify integrity of my higher classification data. So say you have unpublished financial records and published financial records. If I try to reconcile the two, then I can meddle the unpublished financial records, because that will always be either advanced or before the published. So you'll have some work in progress financial records. Once it goes through audit, etc., then it becomes public. And then you'll have next cycle of financial records coming in. You can't simply read the public or published financial record and modify the records which are present, because there will be a difference of time in there, and hence your information gets the integrity principle gets breached. So that is what it is. The people who are at the top or who have access to higher classification shouldn't be able to read the information at the lower classification, because then they'll have information which may not be relevant for higher classification. And sorry. Okay. Somebody, Samiksha mentioned that what is the difference between Bell LaPadula and MAC?
Yeah.
MAC is mandatory access control. Uh, how come you're confused between Bell LaPadula and MAC?
Because even the Mac works on the same logic, right? There are confidential data, top secret data, and I mean, not everyone will be having access to all the levels of the data.
Okay. MAC is Bell LaPadula is a model like OSI. OSI, you're familiar? Are you comfortable with OSI?
Yeah, I mean, the logic remains same, is it? In
Sorry?
both of the cases? The logic remains same in both of the cases?
Not really, not really. So the principle of MAC is that, say there is a, say you're working in an environment where, have you ever worked with SE Linux, security enforced Linux? That is basically the Android, like after Marshmallow, it was SE Linux.
No.
Okay. SE Linux is a example of Mac kind of system. So how do I explain it? Okay. In a Mac system, the system has some rules already written in it. And that may be following Bell LaPadula or Biba, depending upon what was the target of designing that system. Was the system designed with only protecting confidentiality in mind, or only protecting integrity in mind, or and you don't have just Bell LaPadula or Biba to do that. You also have Clark Whistle, which is basically doing the integrity protection. So you can use either Biba or Clark Wilson. It just comes down to Mac is the way you build that system into your environment, and Bell LaPadula is the principle. How do you build it?
Got
Or
it.
if you want to preserve confidentiality, what are the things that you should be doing? Is what Bell LaPadula, Biba, Clark Wilson, these models are. And your Mac DAC is how you do it.
Got it.
Sorry, Karan, please go ahead.
So if my focus is only on say confidentiality or integrity, I'm clear on what model to use. And these would have principles built in, which is very specific. But you also said that if both to be integrated, for example, there is
A model is a model. It will just tell you principles. That if you want to ensure privacy, ensure that nobody is allowed to read up. Ensure that nobody is allowed to write down. If you want to ensure integrity, ensure that nobody reads down or nobody writes up. So when you're building a system, say you're building a Mac-based system, you can write those principles in the Mac-based system that information classification is mandatory, and anything which is classified as such will only be allowed to be accessed by users who are having this permission. Like that. That's it.
understood. One clarity which I want to ask is, I don't know much about this principle. So are there any overlapping
Yes.
guidelines which will affect when and you are forced to decide based on the circumstances?
Ideally, you won't be deciding this. It will be the OS manufacturer or it will be the firewall manufacturer who are deciding these parameters, or for those it is more relevant.
Chandresh, what would help is, practical examples of this being implemented, right? You mentioned OS and firewall, yes, but are there more examples that will help map this much more easily?
Okay. How do we write ACLs?
On the firewalls you're talking about, right?
Not firewalls. ACLs are, like I said, ACLs are a feature of DAC. So discretionary access control. You use SharePoint?
We do, yes.
So if you use SharePoint, there you can extend permissions which are read-only, read and write.
Yes.
I think those are the two kind of permissions, or block download. So
Correct.
those are stemming from these models only.
Understood.
So a Microsoft, when they're designing their SharePoint permission model, they'll be looking at these models that what do I want to achieve this specific solution? Do I want to achieve confidentiality, integrity, or Do I want to prevent conflict of interest? And then they'll define their permissions and roles accordingly.
Got it.
Okay. Then you have Clark-Wilson. Basically, it again preserves integrity by a different method. It says that there can be two types of items or objects. So Usha started with subject and object. Subject is the user, object is what they're trying to access. So there can be two types of objects. One which is unconstrained. So which is, say, public information. I'm okay sharing it with anyone. And then there is constrained items, which I'm not okay sharing with everyone. There you simply enforce some sort of a verification process, and once the user identity is verified, it's something like a zero trust. If it resembles that, it is something like that, but not really zero trust, because that's another principle that may be taking its own inspiration from different models. Then you have Brewer-Nash, which is basically also called as Chinese wall model. It is to prevent conflict of interest. So any one person shouldn't have so much information that they can collude or they can infer things which are higher classification or which can lead to conflict of interest. Graham-Danning, creation on deletion of subject and object. Again, we already learned what is subject-object. This dictates that you should have some sort of a process before creating or a subject, creating a subject or object, creating or deleting a subject or object. Basically, you just need to remember these three, because these are the ones, or these four, because these are the ones that I've encountered more often than not. And again, you just need to remember what principle it preserves and a high level understanding of how does it do it. And once you learn that, it will be simpler to just make sense of all this. Does it make sense so far or not? Okay, I'll move on to the next one. Okay. The quiz is, the question is, Rematech is in a position to acquire sports agency for XYZ amount. The CFO will create a financial statement of the agency's tangible and intangible assets, goodwill, liabilities, and total purchase price. The documents will be sent to a legal and accounting team of both the companies, who will perform their due diligence. After agreement, the documents will be formally approved by the CFO of both entities. The security requirements are that all financial statements, records, and contracts are protected from alteration. So what needs to be preserved? Confidentiality, integrity, availability, repudiation. What is it that we are trying to preserve?
Integrity.
Exactly. Neither party is to directly modify, send, or receive any documents on their own. A custom system application is currently being created to facilitate this process and meet the security objectives. Which security model should be used for the system? So
But
the
we have
keyword,
both A and B, right?
only one is right.
A.
You're supposed to, exactly. Clark-Wilson is the right one, because neither party is directly neither party is to directly modify, send, or receive any documents on their own. There'll be a custom interface through which you can access these documents. And that is what we were doing in Clark-Wilson. For anything which is a constrained item, you go through a separate process of verification. Okay. TCB we have already discussed, so I'll skip that. HSM also we have already discussed. ICS, so yeah, I think somebody asked about it, and ICS are industrial control system, pretty much self-explanatory. This is again a reference model, which is called Purdue model, which is like the OSI model, but it's for OT systems or ICS systems. Now, ICS systems may include everything which has an ability to control something. So that includes your L1, the basic control, PLCs, RTUs, uh, your DCS, distributed control. Then you have a SCADA and HMI. So these are generally your ICS systems. One thing to remember about ICS systems is you'll always, whenever you're dealing with ICS systems, you'll mostly follow the IEC 62443 standard, which is relevant to the ICS systems. And I think the risk assessment one is 3-2. So it has the 62443 has 4 levels, and each level deals with different things. So the level 1 deals with architecture and design. The third is risk assessment level, and that is what is more relevant for any GRC professional for that matter. And the one which is testable is 3-2. So generally we use that. The other thing that to be noted with an ICS system is these are generally very, very constrained systems. And these are generally very, very vendor dependent systems. So say there's a PLC which is installed in my environment. It's a Rockwell PLC. They'll have a factory talk system, which is a controller for the PLC. You can program your PLC with that. You can configure your PLC with that, etc., etc. And it'll follow its own protocols, etc., to talk to the PLC, and which are generally insecure protocols because it was written some 50 years back. So with the ICS environment, and because these are very fragile or very sensitive, and these are generally controlling your manufacturing processes, your utilities, etc., like water utility, electricity, etc., etc. So these are the risk of outage is very, very high than actually securing the environment. So one effective way of securing ICS environments is defining your zones and conduits. Zones and conduits are nothing but your network segmentation. What we do in IT is network segmentation. In ICS, we call it zones and conduits. Zone is nothing but some 3-2. Generally, it is 3-2, but that is the risk assessment location. I think 3-3 is the security profile. Yeah, Mohan, sorry.
Yeah, 3-3 is for system security, that is, and security level.
That's the security profile. You define the security profile of a target system, and then the control applicability changes accordingly. But testable one is 3-2.
Yeah, just I want to add one more here point, because especially normal in ISMS, we consider the CIA triads, see where is the priority number 1. But here we take safety first, then availability is the second one.
Agreed.
Then comes I and A.
Agreed. There'll be physical safety because you're dealing with because people are closely interacting with things that can hurt them.
Yeah.
These sensors can be motors, can be robotic arms, etc., etc. That's why safety becomes the most highest priority. Okay, I said availability, and that's why you're, I think, adding it. Okay, I said risk of availability because it is having a direct impact on your revenue, and hence what I was trying to highlight is generally for any factory professional or anyone who is working in OT environment, they won't consider security at all. If you think IT people are difficult with security professionals, work with OT people once, and your perception will change. So yeah, the key control then becomes this: you put it in a separate network segment so that you can tightly control what goes in and what comes out, and hence you reduce your attack surface, because technically you cannot patch these systems if say Rockwell doesn't no longer maintains that product, or maybe it is such an old device that nobody knows what framework it uses or what language was the code written on, or nobody knows the architecture now, etc., etc. So generally the best defense in this case is to define your zones and conduits very, very stringently, and then follow that network architecture everywhere else. or define a proper network architecture. Zones is the network segments. Conduits is your rules, what goes in, what comes out. So in ICS environment, we typically enforce zones and conduits, and this is the Purdue levels. So generally the ICS devices will be sitting at level 1 and level 2. Cool, your IT boundary starts here, 3.5. That is where your DMZ is. All good with this? Okay. Now, the quiz is, during a third-party vulnerability scan and a security test, Danielle's employee recently discovered that the embedded systems that were installed to manage her company's new buildings have a severe remote access vulnerability. The manufacturer has gone out of business, and there's no patch or update for the devices. So if you see here, the keyword is manager. So when you're reading the CISSP questions, there'll be a lot of garbage information in that. So always focus on the key terms, just like we did. If you remember here, we did focus on this. The security requirements are that all financial statements, records, contracts are protected from alteration. So we know that it is talking about integrity, protecting integrity. So you can filter out your or eliminate your options accordingly. You'll have to work that out a little by solving more and more questions. Okay. Now, the manufacturer has gone out of business. So that is the key piece of information here. And there is no patch or update available for the device. So there are known vulnerabilities. There's no patch to actually fix those vulnerabilities. What should Danielle recommend that her employer do about the hundreds of devices that are vulnerable? Yeah, exactly. I think the people got it right. Mohan and Sanket will be isolating it and moving it in network segmentation, where we can have a tighter control or put a lid on what goes in, what comes out. Cool. I'll move on to the next one. Any doubts in this? Okay. Next, we have containers, a brief introduction of containers. So if you see on the right, that is a hypervisor kind of environment. And one thing that I oftentimes tell people is, if you look at it, or if you remember where we started from on-prem, where there were used to be dedicated servers for everything. And it was more often than not that we used to not utilize the server to its 100% capacity all the time. So all this technological advancement is aimed towards two things primarily. One is effective utilization of resources. So once virtualization came in, it became possible to actually run multiple workloads on a single node or a single physical server. And then making it flexible or interoperable. So when containers came in, it basically solved that problem. That now you can simply have container images, which are OS agnostic, and you can have actually a small kernel built into your container image itself. And you can run it on a container runtime environment. So the primary distinction between a hypervisor and a containerized system and a virtualization environment is, in virtualization environment, you used to run a hypervisor and every guest machine used to have their own guest operating system. We reduced this guest operating system, shrunk it further in the containerized environment. And by virtue of that, we achieved two things again, the same two things. We increased efficiency of the system because now your half of RAM is not consumed by a Windows operating system, or there's no operating system hogging 4 GB or 2 GB RAM unnecessarily. That is freed up for your application. And you have attained interoperability as well. So as long as you have the container runtime environment loaded on your base machine, you can run your app images. The other advantage of containers is these are immutable. What does that mean? So if anything changes on what was the security risk in, what is the key security risk in a virtualized environment, running a modified image or somebody altering the image unnecessarily, adding additional information, adding backdoor, etc., etc. That gets eliminated in containers because these are immutable images. So if an image gets modified, you'll have to discard the whole thing and rerun it. So in the runtime, no alteration can be made. If you remember previously, we used to have file integrity monitoring systems which are running on your core OS areas, so that there's no modification or unauthorized alteration on your OS core files or any file which is important for your functioning. So that risk gets eliminated with the container because these are immutable images, and immutability means is it cannot be modified. How it cannot be modified? If it is modified, it will simply shut down the whole pod and rerun the pod again. And pod is like a virtual machine, like this is a single pod. Yes, Mohan.
Yeah, how this VM is different from KVM, because generally we use KVM also, kernel-based VM.
KVM is a hypervisor in Linux.
That's all.
Yeah.
Okay.
So you can run your virtualization environment on a Hyper-V. It's a Windows component. It's
Yeah.
for free. KVM is just like that. It's the Linux feature, you can say, kernel feature.
Okay.
Then you have microservices. So with proliferation of containers, you have microservices. So you break down a monolithic service. So if you remember the old days, you used to have a big main dot something. If it is C++, Python, whatever it is, whatever language it is, there'll be a main function. Within that, there'll be 10,000 different functions which are called. And if main crashes, everything crashes because that is kind of an orchestrator. That's why it is a main function. With microservices, what we have done is we have taken out all those 100,000 functions which were being called in the main function and given it its own endpoint, so that parts of the system fail, not the entire system fail. We are making the system more resilient that way. So say it's like a client servers. It's an evolution of client server based environment. So how do I explain it? If you remember old operating system, if you worked with Windows XP, it was more prone to kernel panics because the whole system was a monolithic kernel based on DOS. But then the kernel got changed to a microservice based architecture, and everything became a client server kind of approach where OS exposed APIs with which the application can talk and get their job done. So the whole OS was broken down to multiple components. We have done the same with applications. So there used to be monolithic applications which were very big, something like a SAP. Even SAP is fragmented now or modular now. Can you give an example of monolithic applications? Have you worked with a monolithic application?
Sandesh, I'll just give you a very simple layman example if that works.
Yeah, perfect.
See, for example, you're using your Zomato apps, right? To find the address, Zomato does not have its inbuilt map. It takes the help of Google Map.
Google Map API, yes.
Yeah, so it'll call that application, fetch the location, and then do its function. So if Google Map has any issue, Zomato application is still working. It's a very simple example.
Yep, agreed. So you break down the components of an application, a bigger application, and make microservices out of it. And each microservice then works independent of the other, and they can talk to each other via API interfaces. Basically making the system more resilient. If somebody DOSes a single microservice, that one microservice will go down instead of the entire application going down. Okay, then we have serverless computing. Serverless is an advancement brought in by the cloud, the proliferation of cloud. primarily, it is like a function as a service. If you're familiar with Lambda or Microsoft Application Service or app service, that is serverless. So what happens in a serverless is you don't need to worry about the infrastructure, you don't need to worry about the operating system, etc., etc. All you need to bring in is your app code, run it on, load it on the Lambda instance or the serverless instance, and then it can run event-based basis your message queues or whatever MQ system or pub subsystem that you may have, and basis the events, it can just run up, down, and spin down itself. You don't need to worry about what operating system, what hardware, etc., etc. It can auto scale. It can take care of everything. The only limitation with the serverless is it cannot run. It becomes very, very costly if you're running it for a very, very long time. So your functions should be small enough to run in a burst. So say Instagram uses image compression algorithm, they can run it on a serverless function. So every time you upload a picture on Instagram, the compression algorithm runs on a serverless function, which will only take 2 seconds or 300 milliseconds to run, and then hand it over to other microservices. So those kind of workloads, which doesn't need to run for a very, very long time and are required only in burst of time, those can be used, those can be run on serverless functions so that it is very, very cost effective. And that's primarily it. You won't have to worry about the hardware, OS, etc. That advantage is already there. Okay, now cryptography. With cryptography, there are multiple types of cipher suits, or there are multiple types of implementations. There can be symmetric key cryptography, asymmetric key cryptography, and you can have the hashing functions as well. So in a symmetric key, what happens is, or first of all, cryptography. It's basically a mathematical approach to convert something which is legible to something which cannot be understood unless you have the specific information or the secret with you. So in a symmetric key cryptography, you'll have a common key or the shared secret, and that's why it is called a shared secret cryptography as well. You can encrypt the message and decrypt the message with that same key. What's the problem? Problem is sharing that key, because if that secret is compromised, then the message is as good as not being encrypted at all, because anyone who has the encrypted text and the secret can simply decrypt and read the original text. So shipping the key becomes a challenge. And since we don't trust the internet is basically an untrusted zone. That's why we use encryption and all tunnels, VPNs, etc. Symmetric key cryptography has a limitation of using sharing key. So if you share a key across the internet, it is as good as being compromised, unless it is shared on an encrypted channel. That challenge is solved by asymmetric key encryption. What happens there is you have one key, you have a key pair. One key can encrypt, and whatever one key has, one pair of the key, one key from the pair has encrypted, the other key can decrypt. So you have public private key or asymmetric key. If you encrypt something by your public key, your private key can decrypt it. If you encrypt something by your private key, your public key can decrypt it. Now, why would you do that? Encrypting by public key or a private key? There are certain trust principles that can be enforced by using it in a specific configuration. So for example, this is Usha on the other side, and green is me. I want to share some information with Usha, and I'm not worried about the integrity, etc. I'm only worried about only Usha gets to open it. So I'm worried about confidentiality of the information. So what will I do is I'll ask Usha to share her public key with me. And since public key is public knowledge, even if it gets compromised, and somebody encrypts the information with that and shares that with anyone, only Usha, who has the corresponding private key, can decrypt it. So that way you ensure that authentication is there, and basically it is preserving your authentication, not actually integrity. Integrity is hashing. So it is preserving your authentication. How does it preserve that? Because Usha has generated a key pair, private and public key. She shares the public key with me. Even if it gets compromised, nobody can use it to decrypt anything unless Usha shares something which is encrypted by her private key, in which case it will be difficult. But then I'll use Usha's public key. She has shared that with me, encrypt the message, send it out. And that way, only Usha can open it, and I'm ensured of the message being able to be read by Usha only. Actually, confidentiality is also met. So confidentiality and authentication is met. The other configuration is I use Usha's Usha uses her private key to encrypt the data and share it with me. Or yeah, Usha uses her private key and shares it with me. In this case, only her public key can decrypt it. And here again, authentication is or non-repudiation is achieved, because Usha cannot say that uh, I didn't share that information, because it was encrypted by her private key, and it is assumed that only she holds the private key. So anything which is coming from coming encrypted by Usha's private key can be unlocked by her corresponding public key, and public key is already available with everyone, the target recipients at least. And if they can decrypt it with Usha's public key, that means that Usha and only Usha had sent that. So that prevents repudiation, or that enforces non-repudiation. What is repudiation? Repudiation is denying the fact that you did something. So Usha cannot deny later that she shared that information, because she encrypted it with her private key, and hence we know that it was shared by her only. Any questions on this?
I believe the integrity is also achieved because
Integrity
if
won't be
Usha,
achieved.
Usha is also sending the same message, right? Because of her private key, because let's suppose the right side person who is encrypted the data over the public key of Usha's, right? And once the Usha is getting the message, okay, she also can decrypt it. So it means like the right person has given the data and it cannot be tampered. It would have not be tampered. So I mean
What
that's why
happens?
the integrity is achieved.
Okay, what happens if there is a SSL offloading? In that case, you'll be trusting the
Yeah,
SSL box as
yeah, exactly. The SSL decryption case that could be different, but
well.
I'm
Exactly.
saying in a general use case.
So
I'm just opening a Google, okay, and in that case, if Google is not doing the SSL decryption and all, and backread is going to that, then I'm saying in that particular
it
way.
may preserve integrity, but
Yeah,
not always. That's the
not
point.
always. Yeah, exactly. Yeah.
Okay. So if you remember, there was a challenge of sharing the symmetric key across untrusted network. So how do we solve that? We solve that using PKI, which is public key infrastructure. And that is the next topic. Uh, oh, quiz. Which of the following correctly describes a drawback of symmetric key systems? It's a pretty straightforward question, guys. Yes, D is correct. The problem is that you need to secure the key or send it very in a via very safe channel. Computationally less intensive is not a drawback. Location. That's the
Yes,
advantage.
true.
That's why
By
we use symmetric and PKI as well. Okay. Which of the following are services that crypto systems can provide? Confidentiality, integrity, availability, repudiation. Is it D for this? Sanket? Okay, CDD. Exactly. So, Shilajit, why cannot it, why accounting? Like, how will it provide accounting?
Yeah, so in the asymmetric thing, what exactly happens? Let's say if I am sharing anything, so I can't deny that. So I am not accountable
That's
for that
segregation.
particular. Yeah.
Accounting is log, if you maintain a log.
Okay, so in this particular thought process, it will not work like that. You're saying.
Exactly.
Yeah.
So the correct option is D, confidentiality, integrity, authenticity, or authentication. Availability, it cannot, like crypto systems cannot provide basically.
Got it.
Authorization is again something that they cannot provide. Okay. Move on to the next one. Yeah. Here we have PKI. Now it can be slightly complicated, so just a heads up, but I'll try to keep it simple as possible. So what happens in, and you can actually forget about the right part. This is group. Sorry, this will only complicate the matters further. So as I didn't want you guys to get confused unnecessarily. Okay. So if you've understood the symmetric and asymmetric cryptography correctly so far, then what's happening basically is in a PK environment, you'll have a chain of trust. And it is similar to how we trust people in our daily lives as well. So there's a CA, which is certificate authority. Public root is the public CA basically. And they issue, ideally, it will not be as straightforward. There'll be root CA under which they'll be issuing authorities, issuing CA, etc., etc. There'll be multiple layers of that. So what happens is, let's establish first of all. Okay, here's my user who wants to access these services, and the user wants to be sure that they are talking to the service that they wanted to talk to, and that is where certificates come into picture. What is a certificate? Certificate is an attestation of a X509 material. X509 is a IEEE standard. It is nothing but a, let me just share my screen again. Sorry, I'll just reshare it so that I can show you a certificate, which is very simple. Sorry, I'll share my entire screen. I can share my entire screen. Great. So if you see the, wow.
It's like a Matrix movie.
Yes. Okay. It's like OBS going wrong. Okay, let me just open this. I'll share this window. Just a second. Where is that? Folks, you have a window in the background. Let me just take a screenshot of this. More information, view certificate. This is the certificate. Okay, can I share this now? Let me just share this web page. Just a second. Share this window. Okay. Don't share anything. Just a second. Let me just open Safari.
you're opening the Meet page itself, so that's why it is happening. So if you go to the
If I
another
go to another browser window, it'll
yeah.
get fixed. That's what I'm doing. I've changed my browser altogether, so simplest fix to complex problems. If you see here, you have an option to show certificate. Once you click on this, you see this. And if you click on this, to further see this. Now, what are the things that you see here? We see a serial number, we see a signature algorithm, you see what algorithm is used for public key, which is RSA. RSA is asymmetric encryption or public private key encryption. And this is your public key. This is the public key of the opengroup.org, this particular web server. And then what else? So whatever structure that you're seeing here, that it has a CN, which is common name, it has a region, it will have a DN as well somewhere, display name, etc. So all of these things or the fields that you're going to capture in a certificate, that is defined in X.509 standard. So IEEE has defined this standard. This is what it is, X.509 basic policy. Okay. So IEEE has defined the standard to govern all the certifications or all the SSL certificates, and that defines what kind of information will be captured. Sorry, somebody raised their hand or something. More, yeah.
Yes, and just I was asking because generally, if suppose client server is there, so we are getting the certificate. In that certificate, information about the root or maybe in between root and the server, there will be maybe that in the trust hierarchy, we can have. So, sir, this public key will be related to the root, who is the root, or maybe the server side. So, how that is used generally, that public key, especially at the client.
There's a reason why I was showing you this,
yeah,
because I wanted to come to that. And that is called chain of trust. Generally, you'll have a PEM extension to a certificate, which is a chain of trust. Okay, so what is the information that you see here? You see what kind of asymmetric algorithm is being used, what is the size of the key which is being used, what is the purpose of the certificate, etc., etc. All that. It has the hash as well. Okay, so everyone compatible with the certificate, I hope. Now I'll stop sharing and go back to the deck. Okay, so what you saw in a certificate, that is this certificate, or whatever certificate which is installed here in the Alexa. Not this certificate. We see this certificate, Alexa and home certificate, the certificate which will be installed on the application itself. That is what we had seen because we had opened the application certificate. I was on a website, I opened the certificate of that. So that is the application certificate. Now, that certificate contains the public key. Public key of who? This application. That means the application must have a corresponding private key as well. So now what happens? The application will send its public key with the information in the X.509 standard. So your CN, DN, alternate name, etc., etc. Multiple pieces of information are there that you can populate. Some are mandatory, some are optional, etc., etc. So you fill up a form, you provide your public key in that, and you send it out to a CA, certificate authority. Now, what certificate authority will do? They'll bless it. How do they bless it? They bless it with their private key. So basically, they encrypt your public key and the X.509 information that you had shared with them with their private key. Now, what will happen? Since they have encrypted with their private key, your certificate can be decrypted by their public key. Agreed?
Yes, yes.
Okay. So if your public key can be decrypted by the public key of the certificate authority, it should be there with the user who is trying to access your application, isn't it? Because this device is trying to talk to you, and you have got your public key encrypted by the private key of the certificate authority. So what does this device need to have in order to make use of your public key?
The public key of the root, or maybe in between that.
Not root, intermediary or issuer. So you have root, intermediary, issuer. Generally, you'll talk to issuer certificate.
Issue. Oh, okay.
So you need the public key of the issuer, and that's exactly what is there on your device or your certificate store. So if I show you again, and hopefully this doesn't turn out to be a matrix this time. Okay. Let's simply search the MAC trusted root. So, where is that? Teaching. Apple has a tendency of giving fancy names to everything. Okay. Okay, and let me just reshare quickly, and hopefully after this, you'll understand PKI better. So this is my login system roots. If you see here, these are the certificates which are stored in my machine. If I go to certificates, I'll have trust where I have other certificates. Actually, not really. All items, certificates, system. Okay, so these are the entrust. Okay, this is the issuer. DigiCert. These are the issuer certificates. So you already have DigiCert, their CA certificates, their root certificates, etc., etc. You have that in your system. So what will happen now is you, by virtue of, and what does the certificate contain? Certificate contains the public key. So you have the public key of your certificate authority as well, or the issuer. Okay. So that is how the chain of trust is now going to resolve. So my device has the public key of this issuer, who has encrypted the public key of this with their private key. So when this will send their certificate to me, which is encrypted by this private key, the private key of this person or this body, and I have their public key already, I'll be able to decrypt that. That is how the chain, that is how the trust resolves. So now it will, because my system trusts the issuer, it'll start trusting this as well, because it was able to decrypt the certificate of this entity with the issuer's public key. So far with me, are we good?
So it means the client is playing with two public key, one that is coming from the certificate of the server, that maybe I'm opening the browser, I'm getting the certificate. In
Yes.
that I am have a public key. Second, I am having the installed public key of the CA.
Yes.
Using that public key, I am decrypting this one and I am validating that. In that way it is working, or how? Means two public keys are there.
I'm decrypting. So, and both the public keys have different purposes. So this public key, which is the issuer public key, which is stored on your device, that is to decrypt the certificate of the application, the service.
Okay.
Once you decrypt the certificate of that application, what you'll get? The public key of this application. So what you can do now, you can create a session key, which is symmetric key, and encrypt that with their public key and send it out to them. And now you can rest assured that if you have encrypted the session key with their public key, only they can open it with their private key.
Okay, got it.
So once they have the session key, they can initiate a secure tunnel and encrypt that with the session key. So the whole PKI shenanigan is to securely transfer session keys. Why are we so obsessed with transferring session key rather than using asymmetric encryption? Because if only I was using asymmetric encryption, I would have saved some 10 million steps
Make it
there.
process related, because in asymmetric only for initial keys exchange we will be using asymmetric. Then we will be using symmetric
Not
encryption. That's
process related. You're gaining efficiency.
efficiency. Process means processing power.
Okay. Yeah. So it is computationally taxing asymmetric.
Exactly.
And that's why we do this whole drama to transfer the session key to the system so that they can initiate the encrypted tunnel using symmetric key encryption. Cool.
Can you please summarize once again?
Okay. So there is a root CA, there is an intermediary CA, and then there'll be a issuer CA. Okay. You'll have the public keys of root, issuer, root, intermediary, and issuer, all three on your machine. Okay. So this is your machine. The device is your machine. Okay. What do you have? Your public key. Great. You are trying to access this and you want to access it securely. How do you access it securely? When there is an encrypted tunnel between them and you. Agree so far?
Yes.
So what do this person do in order to securely transfer the keys with you or exchange the keys with you, session keys with you, which is symmetric encryption? So they'll create a certificate which will contain their identity information and a public key. Corresponding private key will be with them. They'll share this information, the public key plus their information, basic information, with the issuer. The issuer will attest their certificate X.509. They followed the X.509 format to give the basic information and the public key to the issuer. Now the issuer will attest it with their private key. So once it is attested by private key, you can safely send it to anyone, or basically they send it, the issuer sends it back to Google, and Google will install it on their web server, that certificate. Whenever somebody tries to talk to Google, Google will send if they are requesting HTTPS, which is TLS, Google will send their certificate to this device. Remember, this device has the issuer certificate already with them, the public key of issuer, and the Google certificate, web certificate was encrypted with issuer's private key. So this device can basically decrypt that certificate. Now, what does it have? It has the Google application's public key. So what will it?
When the devices has issuer's certificate, you mean the device browser has the issuer certificate, right?
You have a TJ.
Because we don't ever get that certificate, right?
You'll have a certificate store on your machine. If you have Windows, you can simply search certificate store.
Okay.
Because Windows is also making encrypted sessions with multiple web components, or even with local components if you want to do. Actually, if you remember what we discussed initially in the TPM, you can consider TPM to be a whole root, issuer, intermediary kind of setup. Because what it does is it validates whether your pre-boot environment is attested, and there a PKI kind of same kind of resolution happens. So your bootloader, etc., are checked for their signature. Their signature verification happens first, then only TPM allows to load the bootloader in memory. Because your operating system comes much later in your boot sequence. You start with your BIOS or UEFI. Once your UEFI is loaded, you UEFI search for bootloader. Once it finds the bootloader, it'll look for the signature of the bootloader, and it'll ask the TPM to verify that signature. If the TPM says that good, great, go ahead, then the bootloader loads in memory. And that is what secure boot is. If you look up Microsoft Secure Boot, you'll find it that how the TPM actually backs the whole attestation. But something like a PKI is going on there as well.
So when you say the devices have the public signatures of the issuers, is it pre-configured when we have an asset?
Yes. Yes. So there are known issuers. No, there are limited number of issuers who can issue certificates, like DigiCert. There was Let's Encrypt, which issues the certificates for free. So if you're configuring any web service, you can go to Let's Encrypt. They'll give you a certificate for free for a year, and you can then renew it again on a yearly basis. You can renew it with them. They are a free issuer. So yeah, your computer, your operating system, your browser, everything which is going to create an encrypted tunnel, that comes with its own certificate store, and oftentimes pre-configured with the whole chain of trust.
Okay.
And if there is a new certificate that you're installing, you'll generally install a PEM certificate. What it contains is 3 certificates: root, intermediary, and issuer. Or root, issuer, and application. Application should be there. So root, issuer, and application.
But in case of self-assigned certificate, this will not be
In
required.
self-sign also, you need to install your CA certificates, no?
Okay.
Otherwise, the chain of trust won't resolve. And if you're using a Microsoft-based environment, most probably it is your ADDC which is distributing all the certificates. So you don't ever get to see an error message.
And the whole agenda is that the session, you can set up an encrypted session with the application.
Exactly. You want to set up an encrypted session with the application, and you want to verify the identity of that application as well.
Okay.
And that certificate contains identification information, no?
Okay.
And your system trusts the issuer CA. So that's how the whole chain of trust works.
So how can you test this? Like if you have to see this in your system, can you show it if it's possible?
I'll have to use. Actually, it is not really possible unless I'm using Wireshark and then I'm explaining the whole packet analysis, that this is when the application sent a certificate. But the closest that I can show you is the 2 pieces of information. That's why I'd shown you that my device has a. Let me just. So what I'd shown you before is. Where is that? Allow entire screen. Let me know when it becomes a matrix because I'm not looking at the screen now. So in Safari, if I do Control-Shift-T, yeah, Safari, go with Safari. Okay. If I go here, close this. Say any application for that matter. If you're using, if you're accessing YouTube, okay, well, and you see a padlock here, that is basically showing you that there is a HTTPS session successfully created, which is running on TLS, which is using PKI. So if you see the certificate here, you'll have the Google certificate here. And I have a local proxy running. That's why you see issued by AdGuard. And that is what I was saying. If you have a SSL offloading, what will happen then? Then you'll have to install the intermediary CA in your keychain. And that is what you see here as well. So I can show you in bits and pieces, but showing you in actual how it happens is a little bit tricky because I don't have a Wireshark, first of all, here, and it'll become too technical. I'll have to do a packet analysis in this session, which will basically be beyond the scope of whole CISSP for that matter. Okay.
So if in your system, when the system you're showed, AdGuard is your issuer certificate, right? And when you accessed via the browser, AdGuard ensured that the application certificate was decrypted and provided to your system, and then.
Sorry, I didn't follow you. Can you please come again?
So AdGuard public certificate is there in your system, right? So when you accessed YouTube or format any website, and on behalf of our request, the system sends a request to the application taking the AdGuard certificate, request for their public certificate, and then transfer it to our system browser for the further session.
No. So imagine it like a local proxy. So what's happening is AdGuard is instructed to do a SSL offloading. What is SSL offloading? Oh, wow. Okay. You don't need SSL offloading for CISSP, but I'll explain it anyways. If you want to do content filtering, and that is what AdGuard is doing. As the name suggests, it prevents ads system-wide. Other than that, I've put more filters in it. So it does crypto miners blocking, etc. Like you can configure tens of hundreds of thousands of rules, which I've, by the way, configured. And this is like a local proxy. So like I explained in the proxy, did I explain proxy? I didn't. Okay. So what's happening here is in a regular TLS session, what will happen? My computer browser, this Safari, this will go to Google and ask Google to share their certificate. Google will share their certificate, and Google certificate may be signed by somebody, Entrust or somebody. And that certificate is here. System roots. Here you'll find all the global sign, Entrust, GoDaddy, whatever. So all of these are issuer, root, intermediary certificates. Okay. So Google certificate, the original certificate. If you see in your browser and open Google or YouTube, you'll find a different certificate issued by somebody else. So those are these certificates. Okay. Google is sharing that, but AdGuard is intercepting that. Why is it intercepting that? Because in an end-to-end encrypted tunnel, if there is an encryption between my browser and Google's server, then nobody can see what is the traffic flowing in that tunnel. But I wanted to see and filter out elements. I wanted to remove any ad. I wanted to remove any malicious URLs. I wanted to remove any crypto trackers, etc., etc. Multiple content filtering. I want content filtering. So what AdGuard does in that case is it will break the session for me. So I'll have an encrypted tunnel between AdGuard and since it is a local system, my browser will create a session between AdGuard and my browser. Okay, so there'll be one tunnel between this, my browser, AdGuard. Then AdGuard goes ahead and creates a session with Google. So the tunnel between Google and AdGuard is end-to-end encrypted, and the tunnel between my browser and the AdGuard is end-to-end encrypted. The benefit is now AdGuard can simply see the content in plain text because it is offloading the SSL channel. Does it make sense?
Yeah. So here you had the requirement of bringing in AdGuard as a CD and filtering. But what if I don't wanted that, whatever filtering you wanted? In that case, browser will directly do that.
Exactly. And that's why I said that you can open in your browser YouTube once, and you'll find a different issuer there.
Okay.
You're seeing a different issuer in my case because I'm using a local proxy.
Understood. Thank you.
Cool. So that is what PKI is. Actually, we have learned a lot many things than PKI, but yeah, I hope it will be useful eventually.
Chandresh, there is a lot of material out there, but anything that you would like to suggest for us to go do a deep dive on PKI?
You don't need, honestly, you don't need a deep dive of PKI. You just need to understand PKI because the protocols are what you need to understand better than PKI. PKI again is like a concept. It's already, it's nothing beyond that, whatever I explained here. So what will happen now is if you're going to use DNSSEC, and if you understand the concept of PKI, it will look familiar to you. If you want to understand TLS, it will be going to use PKI to some extent. So any protocols which you see an S afterwards, after which, so for example, FTPS. So all the legacy protocols, they have onboarded TLS session, TLS tunnel in it. And once you have that protocol encapsulated within TLS tunnel, is when you call it a S protocol. So HTTPS, FTPS. That is what it basically is. That S is for TLS. or they call it secure. Basically, it's a TLS encapsulation of that protocol.
So, Chandras, I have one question
Chandras, because
related. I have question related exam point of view because this concept is clear for me. Exam point of view, like in the PKI, does it contain like it will ask the certificate format and any other technical questions, or it will be just a
It may,
generic way?
you should be familiar with X.509.
Yeah.
And you
Okay.
should be familiar with whatever I explained in the PKI. Beyond that, you
Yeah.
shouldn't be worrying about anything else. SSL offloading,
Okay.
etc., is not important for the
Okay,
exam.
so it will not ask like we are using how the DER format used, how pen format will be used, or
Most definitely, it won't ask you.
okay, okay.
Like most probably, not definitely. Most probably, it won't ask.
Okay, it will not go in deep. I mean, it will be generic questions kind of.
Yes, yes.
Okay.
But see, it's always a good idea to have a technical understanding of how that thing works, because otherwise it will look like magic, which is not a very great place to be in.
Yeah, okay, sure. So concept wise, okay.
yeah, Chandris, one point related to PKI, because one thing is okay, cryptography for certificate point of view. Second is PKI, where we make a whole infrastructure to issue a certificate, because at the local level also we make a you can say that for revoking the certificate, for issuing the certificate, for generating the certificate, that whole thing will be considered as PKI. Am I right with respect to infrastructure point of view?
Exactly. There is a reason why I had removed the left side of thing, and that is what your private CA is. You're talking about this. So you'll have an internal CA, which is issuing, revoking. You have CRL, certificate revocation list. You have there's a protocol also, online certificate status.
To validate.
Online certificate status protocol, OCSP. Yes, it is OCSP.
So only my point is that PKI means this will cover all, not only the encryption, not only the this encryption and certificate change, but also the whole process.
Certificate revocation is a different entity or a different thing altogether.
Okay, that will not be covered at an infrastructure point of view. Means
yes, PKI as a concept is just this, whatever we have discussed in PKI. Okay. Everything else is your key rotation, certificate management, secret management. That is what that is, certificate rotation, etc.
Okay.
That comes in secret management part.
Okay.
Okay. Then once you have cryptography, people would want to break it as well. So analytics is basically trying to break the cryptography. There are 3 ways to do it: ciphertext only, chosen plain text, and chosen ciphertext. Ciphertext only is when the attacker has only knowledge of ciphertext. They try to take that ciphertext, try to reverse engineer it. If they get succeeded, which is not possible with most of the modern algorithms, unless they are using quantum computer for a asymmetric RSA, because that is potentially breakable by a quantum computer. It shouldn't be possible unless you're using strong key. So your size of key matters. Generally, it is for AES 256 plus. Okay, I missed one thing. Where is that? In symmetric, you can run it in 2 modes, block and stream. There are 2 modes to operate it. Block cipher, you'll take the full message, make it in small chunks, and then you simply encrypt it like that. And there are multiple ways to. So what do you want to do is you want the system to be as random as possible, or the ciphertext to be as random as possible. And to increase randomness in block cipher, you can use the previous encrypted block to initialize the new block, etc., etc. So there are multiple combinations in which you can enforce a block cipher. So AES also works in CBK, which is cipher blockchaining. Sorry, CBC, cipher blockchaining. There are multiple modes of that. In the book, you'll find the multiple modes. And the stream cipher is basically, as it explains, as the name is suggests, it is stream. So any streaming applications where like voice, video, etc., where real-time encryption is required, there you simply use a XOR function. So you create a random string of characters, as random as possible, and XOR that with the message bits, bit per bit. So that is what stream cipher is. Okay, now cryptanalytics. Cryptanalytic attack, trying to break the cipher, and you can do it by having the knowledge of ciphertext only. If you have knowledge of chosen plain text, so if the system is accessible and you can basically decide what plain text to give it and then observe the ciphertext accordingly, then you can maybe detect a pattern in that. So that is what chosen plain text is. Then you have chosen ciphertext. So basically you can pick a plain text and a ciphertext of your choice and then try to figure out a pattern there. So it is simple, nothing rocket science here. Not very important from exam point of view. Only what you need to know is, and these are pretty much self-explanatory. So it is basically telling you what kind of knowledge do the attacker has. Does the attacker know ciphertext only? Does the attacker can use a chosen plain text and then observe the ciphertext? And can the attacker choose a ciphertext and then see the plain text and map it or try to reverse engineer it? So this is basically what knowledge do knowledge or access do the attacker have. That is what it is about. Then finally, we have ransomware attacks. So while cryptography does so many goods, there is a few bads that cryptography can do. One of which is ransomwares, which have been rising in numbers lately. So what happens in a ransomware attack? I hope you all are familiar. You want to give it a shot? Anyone wants to give it a shot?
Yeah, maybe by a phishing or by a different way, they can inject.
Forget about this slide. I'll stop sharing because conceptually, Mohan, what is ransomware?
So availability, making system unavailable and asking for money to make the system again available.
The key word is ransom.
Yes.
So any malware which enables the attacker to ask for some ransom in return of something which is useful to you, that is ransomware, theoretically.
Yeah.
Delivery can be, if you're familiar with the Lockheed Martin attack, cyber chain. Have you seen that cyber chain? Let me just share my screen. You have seen cyber chain. Okay. All of you have seen cyber chain?
Yeah.
So the weaponization, delivery, persistence, etc., all that can be any TTP. So kill chain augmented with MITRE attack. It can be any method followed by different APTs. The idea is they are going to make something important to you inaccessible by means of encrypting it, symmetric encryption again, and shipping the key out. So if you want that information back, either you can re-image your system and restore from backup. Typically, that is what people used to do. Then there was a cat and mouse game happening. So attackers caught up with that and started encrypting backups as well and started delaying the whole detection. So evasive methodology was introduced. And then finally, people made everything geo-redundant. So attackers caught up to that again, and they started publishing information in darknet so that there's more pressure on people to pay quickly and get their information back. So ransomware theoretically is that. Delivery, weaponization, and persistence, etc. Again, the MITRE attack framework can explain it much better than I can do. So I would suggest just have a look at that. And just search by any APT for that matter. Have you guys seen MITRE attack?
Yes.
Yeah.
So if you go there, you can pick up any APT for that matter, and then just have fun with it. Like what tactics, what procedures, what tools do they use at each stage is what MITRE attack does. So like you were saying, Mohan, that maybe phishing or something, it's quite possible that for initial access, one APT does phishing, other APT does some other social engineering campaign, maybe smishing, they send SMSs, or they do other social engineering. So broadly, social engineering can be one point for entry. Instead of being, again, focus on the tree, not the branch. So you start with uh, social engineering, and then social engineering can be done in multitude of ways: phishing, spear phishing, smishing, whaling, etc., etc. Cool, guys. That's it from my side. Let me just is Gitu here? Geetanjali?
Chandresh, what is it about? I'm there actually.
Okay, feedback. The feedback form. Can we float that now?
The feedback form, she'll be sending it on email. I'll ask her to send it on email.
Fine. Okay. Great. Okay. Thank you, guys. Thanks for joining. You can scan or to follow us or connect with us on LinkedIn. And like we began with, please feel free to ping if you have any doubts.
Also, I think Usha had something to say in the end.
Yeah, sorry. Please go ahead.
Usha, after you finish, just give me a minute.
Yeah, nothing much.
Lokesh has raised some question, I think.
No, sorry.
Okay. Yeah, Usha, you can proceed.
Yes, there's nothing much. I just wanted to talk about my experience of CISSP and things like that. But I think over the discussion throughout, we have discussed a lot. It's just that I wanted to say, like, CISSP is just an overview. You don't have to get into much technicalities of it. That is one part. Secondly, it will be, two types of questions. Is that what you could see throughout? Will you be sharing these slides?
Yes, slides will be there. You'll be uploading on Sci portal. Any other doubts?
Any other queries? Any other doubts?
Okay, sure, you can continue.
Yes. Yeah. So what works is this, you'll find two different type of question types. Mostly one will be like straightforward questions, and the other one will be majorly on, testing your managerial skills. So those two parts you have to prepare. Uh, the other thing that I did was, prepare notes. Once I study one particular domain, have my handwritten notes, and then go through them every second day, third day, so that I refresh on the topics. Of course, I took a boot camp from Prab Nair, so I was going through the coffee shots of what he has on his sites. Those coffee shots really helped me. And then there is something called destination certificate on YouTube. It gives you again, a consolidated view of each and every domain. If you can go through that, you will get an overview of what is covered in one particular domain. Then you can, start preparing accordingly. Group studies is what helped me as well. So we were like a couple of people who joined together, and every evening we used to sit for some time and exchange notes, exchange thought, discuss some questions, understand why this answer is correct and why the other three are not right, something like that. And of course, time management is something that you need to keep a track of. So before you start go for the exam, at least you can start solving the paper, set a timer for yourself, and see whether you're able to solve, like in 3 hours, whether you're able to solve 150 questions. Time yourself. And when you do practice questions, the other thing is, like, when you do practice questions, whichever questions are wrong, right, focus on them, because that is your weak areas. Try to work on your weak areas, because this exam is a CAT exam, right? It will test your weakness. It will understand what your weakness is and start throwing you those questions. That is one thing I wanted to say. And yeah, take 1 week leave before you go for the exam and prepare well, so that your mind is free and you're constantly working on the concepts of CISSP. This is what I wanted to say, Seema. That's it from my end.
Thank you so much. I think incremental learning is what you want to emphasize. I mean, where you learn something today and you have to revise it in a day or two so that you don't forget whatever you learned. So that's an incremental learning. Anyways, I mean, she has given enough, and we also have a video on that particular subject as to how you can prepare, how you can plan for the CISSP. It is available on LinkedIn. Maybe I think it's on demand. I'm not very sure, but it is certainly there. We first started with that particular session itself, and then we wanted to do a deep dive and give a in-depth knowledge of CISSP for all the aspirants who are working and want to achieve this certification. So with that note, I wanted to just share one more uh, I mean, what do you call? Just wanted to let you all share one screen and share the information what we have for the upcoming months. Just a minute. So, just a minute. So we have this Bangalore chapter web page. You can go on to this, and we have upcoming webinars on domain 4, domain 5, and then there is a monthly event which is happening on 22nd of March, which is with Netscope. You can participate in that as well. You can register for it, and you can see few of us in person. And this is a domain 1. Whomsoever was not able to attend or not able to take the event or didn't participate, if you want this is available on demand. You can purchase the course. And on the side you will have all the courses which are completed, and you will have the PPTs as well available. We have an annual summit which is going to happen in September. You can purchase. We have pre-release tickets available, pre-offer, so you can avail those as well. If you have any queries on anything, you can certainly email us at support@csabangalorechapter.com. Also, one more thing I wanted to tell is, after this first the monthly event of March, we have another monthly event in April, which is on 5th of April. You can even come to those events as well, where you will get a lot of people whom you can interact and get knowledge, insights, and also networking. And one more thing is, when you interact with them, you'll get to know many more things, and many other courses or any future requirements you want to discuss also, you can certainly do it. We have other courses which we offer, or trainings which we offer is on CCSK, I believe, which is from the cloud security. You can take it as well. That those courses you can avail. If you want any information around that, you can certainly mail us on support@csabangalorechapter.com. Any doubts, you can reach out to us. We will be available to respond to your queries. Thank you, guys. Thank you for all your patience. And it's been a long session. I know everyone would be hungry to go home and have food.
Seema, just a short question. Sorry. Thank you, Usha, for sharing your experience. I have just a question.
Sure.
I'll not take much time because time is precious for everyone. Like some of the domain which is not totally related to me, like software development and security and security assessment testing. So how do you prepare that kind of domain which you don't have any relation with? So any best practices you can share, Usha, for that?
Yeah, Chandresh. Actually, there are certain domains.
Lokesh, yeah. Hi.
Oh,
No
sorry.
issue.
Lokesh. Sorry. This is a problem with everyone
Exactly.
here, because we are not working on every domain of CISSP, right? of course, I may have an expertise on one domain, but not the other domain. And it is a general problem. So what we have done, and we had this group, so we had people from different domains. If not that, the best thing today is YouTube and ChatGPT. You ask the simplest question, you get the answer.
Okay.
It may sound very silly, but yes, it is very informative. Knowledge is just available. You just have to give the right prompt and like search for the right things. You will get the knowledge. Just do some Google, read some books related to, I mean, not books, but at least if you just high level topics, whatever is there in the CISSP topics, right? Just try to Google them, or try to go in search of any YouTube videos or ChatGPT. You will get very good answers. That is one way of learning. Chandresh, you have any input from your end on this topic?
Okay, so location, but like Usha mentioned, the resources will be the same. I would say just identify your weak areas first. So if you're not comfortable with one domain, take the full practice test of that one domain and figure out what are the aspects of the domain which you're actually weak in. Because even if you've not worked in software or application software development, you may be familiar with a few things that probably you do not know and which are part of the CBK, Common Body of Knowledge of CISSP. So just identify the areas. So it may not be 100% of that domain that you're not familiar with. Maybe you're not familiar with 60% of it or 50% of it. Then you can focus your effort on that. Just research the topics which fall in that 50%. And for research, you can use YouTube, ChatGPT, whatever it is. I would say use ChatGPT with caution, but yeah.
Yeah, exactly. We'll get a lot of wrong answers still.
And it has a tendency of being overly philosophical, so it can generate
Sometimes
answers
it may
sometimes.
mislead also.
Yes, it can generate answers at times because that's its job.
Yeah, sure. Thank you for your help for session.
Cool, no problem. Thanks a lot for joining, guys. Is there anyone left here? 12 people are left.
Thanks, everyone. We'll be sharing the feedback. Maybe you can give your feedback on the areas of improvements or any other suggestions you have. You can certainly mention in those feedback forms.
Yeah. Thanks a
Thank-
lot, Seema and Usha.
Thanks,
And
everyone.
Geeta.
Thanks.
Thank you. Thank you
Thanks
so
for
much.
Thank you
joining.
everyone for joining. Happy weekend. Take care. Bye.
Happy weekend.
Yeah.
Happy weekend. Bye.